please take seats. Hi, I'm Boris Weitzman. I'm the outgoing president of Tech Users Group. And I was given some time to open this conference. When one of the questions I always asked during all the years of I have been a president is, what do we do and why do we need for tech as a tech users group? And there were several things we do. One is, of course, Tech Live. It's important thing. Second is a tugboat, a journal which brings us all together. And the third important thing, last but not least, is conferences. A place where people can gather to meet, and they give a lot of impetus to tech development. Unfortunately, for the last several years, we were not able to gather in person. We canceled the conferences when COVID started. Then for 2 years, we had online conference, which was, of course, it was something important, but not as good as coming together in person. And now, due to absolutely great work of the organizing committee and the local organizing committee, and thanks Ulrike, we were able to come together and start this conference. The first in-person Tech Users Group conference since the beginning of COVID. I'm absolutely happy that I can finish my presidency by opening a real Tech Users Group conference. And thank you everybody for coming here. I absolutely hope that you will not regret the decision to come. We are having 2.5 days of absolutely great talks. We have very interesting cultural program. And speaking of something which is not in your documents, Frank asked me to tell you that he brought several copies of the new LaTeX companion. They are very heavy, and he absolutely does not want to bring them back. So we are going to raffle them at his talk on Sunday, so it's another reason to come to this talk. And if you win this raffle, then you are going to lug this absolutely heavy and fascinating book. For those who did not buy the PDF version, which has everything, but it's much, much lighter than the physical one, come and you may get it. Okay, let's start. And who is the chair of the first session? Alan. Okay. Alan is going to introduce everybody, and I'm going to introduce Alan Wetmore, one of the longest, one of the people you have seen most longest in our conferences. When I started, I saw Alan Wetmore, and in all the conferences I have been, I saw him. It's absolutely fascinating.
Thank you, Boris. All right, we're going to have plenty of time. The talks are 1/2 hour. I will give a warning with 5 minutes to go, and that's the 5 minutes before the discussion at the end, 5 minutes. So it's a 25-minute talk with 5 minutes of discussion. If everyone keeps the time, and because everyone's presentation is already uploaded, it should be just fine and everything will go smoothly. I hope you all are enjoying it. It's nice to see a crowd like this. It's just not the same staring at your computer screen. Our first talk will be lighthearted to get us started, so you won't necessarily have to think too deeply about it, but you should enjoy it. Behind the scenes of the great TUG's Christmas extravaganza, Ulrika und Gert Fischer, Carla Maggi, Paolo Sereda, and Sam Carter. They're going to come up here and dazzle us.
Silence the phones.
Yes, please. The chair is always right, so please silence your phones if you haven't done so already. Right.
The slide.
So we've taken first place to be the guinea pigs anyway, and if something goes wrong, it will hit us, and not the more serious. Here it is. Good morning to Bonn. Welcome, everybody. This is the weirdest moment of the conference. The person speaking just now for about a minute or so is the only one in this room who doesn't know a thing about computing and can hardly get his iPhone working. All the same, I was asked to open the talk. You can see what it's all about. You see the curtain behind the scenes of the great TUG's Christmas extravaganza. We thought maybe we should dedicate it to our outgoing president because he's been a fervent supporter since the first year when we produced it. When was the first year? 2017. So it's been going on since 2017, and Boris Weizmann has been one of those who supported it right from the beginning, and we always got a favorable mention in his New Year's letter, and this is something which the new president, of course, will have to carry on, because this is an important tradition. So, it's not light. We're talking about the dark side of text and latex, because you're doing serious things, and this isn't so serious, although, as you'll see in a second, there's some serious programming in the background. When the curtain rises, as it does every year around Christmas time, on the stage appear, Barbara would say, little critters. We prefer to call them inhabitants of the ecosystem of the TUGlings, which is somewhat nicer, and they move about and they sing and do strange things. Musste man den zweiten geben? Right, and those are the people behind the scenes. We've got, it's down there. Oh yeah, this is clever, whoever devised that. So it's Sam Carter. There she is, and she'll do most of the talk. And we've got world-famous Paulo Sereda, Ulrike Fischer, Carla Maggi, and obviously you can see Professor van Dijk. He's always supporting her. Then it's my little self, and then we've got a very important assistant. This is Bear, together with Il Professor. It makes sure that we keep contact with the TUGlings, because we are only humans and we don't really know about all that. And I should also mention that if you look at all the extravaganzas of the past, we've always had collaborators. This is sort of the kernel of the team, but anybody who likes that is invited to produce their own little films, and they'd be included. And we have had some friends who did it in the past. I remember Plurgux, who else was there, who did something for us? Marmot helped us. Yes, anyway, you are invited. So this is the people whose fault it is that you'll be seeing this talk, and at the very end there will also be a little film, and we hope you enjoy it.
So, I should explain how it started. It started, like many things in my life, that my husband had an idea, which means I should do something. And naturally, Bear supported him quite enthusiastically. As he said, he has no idea about videos or about tech or about something with computer, and so I had to start it. Naturally, but then some very artful and detailed storyboards were created, quite large lists. I only show a few examples. You see there, quite detailed. Obviously, one has to know what should happen in these scenes. At the top, there's a title with a short descriptions, lots of points to describe the ducks, and at the bottom, the music that should go along with the scenes. Everyone is invited to find out in which video these scenes were at the end. The middle, if you can't read the script, in the middle it says Queen Duck and Land of Hope and Glory, lots of ducks of all sorts, Christmas ducks, many, and the Vienna boy. So, Paolo, it's your turn. Paolo should come. Paolo. Paolo is for the next. There you can look.
So there was this beautiful morning that I got an email in my inbox asking for some help in an interesting project, and it was quite intriguing, but we decided to bite the bullet and see how things would turn. Of course, as you all know, every journey starts with just a few steps, so we simply, like we did a walk in the dark to see what was going to happen, and the rest is history.
They asked me to comment this slide because I match all these points. and I can also add that my English is poor. And so the philosophy behind this slide is it doesn't matter if you don't know anything. You can learn. And you can learn having fun. And if you learn having fun, you will never forget what you learned. So have fun. And we can go.
So we created many scenes, as you guys saw, Gut's storyboards and the former slides, a couple of slides back. And since this was new for all of us, we had to use some sort of some sort of ad hoc solution to it. So we create separate scenes. They had no audio. We created the intermission cards, and then we had the soundtracks for each of those little scenes, and we had to put them together. Back then, I used to have an iMac, and I had iMovie installed. So I did pretty much a manual video edition, and put all of those scenes in place. I had to align both video and audio, of course, according to each soundtrack, and intercalate those things with an intermission card. So that's basically how the first video was composed. Of course, I exported it to a proper video format. I did some encoding to decrease the file size, and then we had at least our first experiment in this project. So of course, since I uploaded to my personal Vimeo account, Yurik and Gut, they offer me the possibility of announcing it. So we told everybody that we had this wacky video there, and of course it was fun, it was interesting. I think it was one of the first times people actually used PDF for doing some step-by-step animation, but it was a pleasant experience overall for us.
And the next year we got professional because the people we made the present for the TUG video decided to join the team, and now she will explain what we are doing now.
Okay, let's get technical and look behind the scenes how we use LaTeX to produce the video. The basic idea is that we produce a multi-page PDF and convert this into a video to get an animated movie. First, let's look how we produce the PDF. There are many possible ways. The way we use most is a combination of Beamer and TIGs. We use Beamer because it makes it easy to use the overlay mechanism to repeat the image with small modifications. And TIGs makes it easy to position the elements on the page. If you would like to know how we did a particular scene, we have all of our source code on GitHub. Here you can see the address where you can find the source code. Showing the real source of a whole scene might be a bit long for this talk, but here's a short version. As you can see, we use Beamer and use the pause command from Beamer to create multiple pages. And we use TIGs to position the small little bat here. And we position it depending on the page number. So when we create multiple pages, we get this animation. Okay, why doesn't it? Yes, it's not moving. Okay, now that we have a multi-page PDF, we need to somehow convert this into a video. The first step is to convert this into a pixel graphic. We choose PNG as a format because many of our actors, the ticklings, consist of simple geometrical shapes. And with the sharp edges, PNG is well suited because it does not introduce any artifacts. There are many different approaches one could use to convert the PDF into images. The most widely known is probably the convert command from ImageMagick. But this is a bit heavy on the CPU of the computer. So after a bit of experimentation, we now use PDF to PPPM from the Popular ecosystem. This is a bit easier on the computer because it takes one page of the PDF, converts it into an image, takes the next page and so on, and doesn't read the whole PDF. So after the conversion, we have a set of numbered PNG images. To convert them into a video, we use FFmpeg. This combines the individual images into a video and also adds our selected music to it. The result is an MP4 file, but this sometimes had difficulties on some operation system and some media players. So to make sure that the video really works, we pipe it through Handbrake. This does some magic to the encoding and whatnot to repair the file. So in the end, we have one small video for every scene of the extravaganza. Now you probably don't want to watch 20 scenes as individual videos, so you want to stitch them together. As Paolo already mentioned, we started out by using iMovie from macOS. But during the years when we repeated this process, we redefined our requirements. We need to add some transition between the videos so they are more pleasant to watch. We would like to adjust the volume of each video individually so that not one clip is very loud and the other is barely hearable. And something we noticed in the process, we really want to have this scriptable. In iMovie, we had to manually drag and drop the files and arrange them. That's okay if you produce the video once. But in a project of this size, it turns out that even if you think you have the finished video, you find a typo or you find some other small problems at the last day and have to redo the video. And that's much easier if this is scriptable. So now we use the Python package MoviePy. The script to merge the videos is a bit on the longer side. If you would like to see the details, they are available on our GitHub page. And after using this tool, we again have an MP4 file with all the videos combined. And then we again pipe the videos through Handbrake to fix any possible problems with encoding and also to reduce the file size quite a bit, which is nice when we want to share this online because not everyone would like to download a very long file. And as Paolo already mentioned, our platform of choice to share the video with all of you is Vimeo. If you would like to catch up on recent videos from the last years, maybe you missed one, we have links to all the videos on our GitHub page in the TUG links organization.
Well, that was great. We have a minute or two. If you don't have a question, you could always think of a suggestion for next year. There's still a little time to work on it, I think. Does...
Very impressive. I'm wondering, you just talked about the sort of technicalities. How many images are you actually generating in order to produce a video of that length? How many images are we looking at to actually?
Okay, so 25 images per second, and this is around about 1,000 images for every scene. So make it 15 or 20 scenes per extravaganza, a lot of pages.
So in TIGs there is also native support for animations using the DVI-SVGM backend. Have you thought about using that to create your animations?
Thought, yes. I'm not sure how to combine it with the audio and convert it to video. So if you know how to do that, you're really welcome to join us for the next extravaganza.
Well, thank you, everyone. Like I say, it's always enjoyable. Our next talk will be by Oliver Kopp, JabRef as BibTeX-based literature management software. He's cleared the stage. He may be tap dancing in a moment.
Thanks.
That will help.
Okay, thank you. Thank you for having me. I want to talk about my hobby project, JabRef. Left one. And I want to talk to you about three things. First, JabRef as tool and the core ideas behind JabRef. Second, I want to show some features to attract you to use it. And third one, how we use JabRef as object for software engineering education. So that it's not only a tool for us, but also for students to learn something. And I would like to know who of you knows JabRef? Okay, that's good. And who of you uses it? Okay, that was clear. Maybe after slide 5, there will be more. Okay, let's see. This is the JabRef. Maybe it exists since 20 years, so maybe you have seen the old UI and then see, okay, well, this is rubbish. Also, we got comments like, you can't use it anymore. It looks crappy, but now it looks nice because we modernized it quite a bit. And if you look into the UI and open a bib file, you see a table of all entries you have in your bib file. And then if you click on something, then entry editor opens, and this entry editor groups the BibTeX fields. So if newcomers use BibTeX, they got some kind of orientation like required fields, optional fields, other optional fields in case of BibLaTeX, some general fields, comments, and so on. And what it also offers, a pre-rendering. And you can configure it with the citation styles to use IEEE, ACM, and so on, so you get a kind mirror of the output generated by LaTeX. And JabRef is not only displaying it as a table, it also allows you to search in the web and to group entries. So this is the overview of the GUI, but before I explain you the web search and the grouping, I want to show you the core idea of JabRef. And the core idea is to use BibTeX as internal data model, which means there's no conversion between BibTeX and some internal proprietary format. We use BibTeX in the core. I put a short example entry being an article with a citation key, having an author, and then I show you the data types used in JabRef. And the data types are stored as enum, and we have all standard types encoded, as well as enum entry, like article, and so on. But we implement an interface, so JabRef can also be extended with customized entry types, like if you want to collect persons, for example, or software things, and whatever, you can extend it. And also as user in the UI. And the field, also same idea, having an interface, having the field properties, and we encode all standard fields and have some field properties so that the UI knows how to display these fields. And finally, at the end, everything is a string, so we map from the field to the content. But then you see here some observable lists, and this is one reason is because we are based on Java FX and directly connect the data in memory to the UI, so if there's some change, then it propagates through the tool and everything works as expected. So this is the core idea. And now let's look what we build upon this core idea. There are features. We start with an empty library, and now we want to include new entries there. And one thing is web search, and JabRef has built in multiple libraries to connect to and to fetch them data from. The German famous DBLP for the computer science ones is there. There's also the Karlsruhe collection of computer science bibliographies, but also ACM and Archive and dozens more. And we just connect to the service and use their API to include it. And here's an example. I queried DBLP for JabRef. 3 entries come back. And then JabRef pre-renders the search result, and you can say, okay, I want to have the first entry. And if you said, okay, then it goes into JabRef, and there it is, without any more things. And then here you also see our BibTeX source panel, and this is the thing how it's also stored internally in JabRef. Okay, now we got the first entry in, but maybe you have PDF files on your hard disk, and you want to have a proper bibliography based on your PDF on a hard disk. How to do? One possibility is to drag and drop the PDF into JabRef, and then JabRef looks into the PDF and extracts the metadata from it. So in this example PDF, it goes like, okay, here this paper is from Igor and B, which is a mistake. We'll fix it later. And Marco and so on, with the title, year, and the number was also something not that okay, but the rest looks good. So this is a good first guess how to fix. Then we jump to the next feature. You go in the editor to the tab General, to the DOI, and click on Lookup DOI. Wait a second, and then there is the DOI of the thing. Next click, fetch bibliography information from the DOI. Here's the original one, which you saw with the on being wrong and with the authors. And then here you see the information of the DOI, and now you can pick and choose. Do I want to have the original one? Do I have to have the new one? And you just click, okay, I use that, I want to add, and so on. And then you click on import entries, and then you have got the final entry inside the JabRef fixed. Now we got 2 entries in JabRef, one from the web search, one from the PDF, and maybe we think, wow, there will be much more, and how to organize that. And JabRef offers the feature of grouping, and here I put 2 groups in, software engineering and JabRef, and I assigned this user feature paper to the JabRef group, and you see it here in the BibTeX source, it's just the field groups. And the groups list all groups this paper belongs to, and here it's written JabRef, so JabRef knows, okay, this paper belongs to the group JabRef, colored in purple, and you also see here the purple arrow, so that you can visually see when browsing through the table to which group your paper belongs to. And this can grow and grow to thousands of entries, and JabRef still runs, and you can still query the thing in the JabRef UI. Okay, but what if you don't start with an empty library? You have got some existing library, and maybe you don't have your BibTeX because you started it at another world, like Citavi or EndNote. What you do? Plain simple, you go to the file menu, click import into library, and then JabRef offers dozens of formats. And one of those formats is Citavi XML. So you put your Citavi backup file somewhere, and then you can import it into JabRef, and it works. And we also have the mods and EndNote and whatnot. And after the import, the entries are there, and you can work with them and do some quality assurance so that they get even better. Speaking of quality assurance, and going back to our initial example, with the 2 entries, JabRef offers a quality check called check in integrity, where it goes through all entries and checks for mistakes. And here are 3 example mistakes. Like capital letters are not masked by using curly brackets. You know, in BibTeX, the titles always go lowercase, and maybe if you have JabRef in your title, the R should be capitalized. So, and then the thing now says, okay, please check it. Second one was month should be normalized. The pros of you know that there are several ways to write a date in BibTeX, and one could have a whole talk about that. And here in the entry there was a curly braces and then the month written in, but it should be a number, and JabRef reports that. And finally, the thing is with the citation key. Citation key derivates from generated key, which means if you have your BibTeX entry and the BibTeX key in front, JabRef also offers to generate a key so that you have got a consistent bibliography with consistent keys. And let's fix that. And it's easy again. You go to the entry editor, go to the citation key, and there's a button, generate key, and you click on it, and it's generated with the default key. And you can also configure this pattern. As this is like each year JabRef changes the default somehow, and now the default is the first author's name in the year. And if there are duplicate keys, it just adds A, B, C, D at the end. But you can also configure that, how you want to have that working. Okay. JabRef being now 20 years old, or at the end of the year, there were so many ideas collected how to fix things. And we have got a crude menu, but this collects all our knowledge of fixing. If you click on clean up entries functionality, we are offered many things. Like the first example is to move a DOI from the node and URL field to the DOI field and remove HTTP prefix. Like normally, if you fetch entries from the web, the DOI is then spread around various fields, but you want to have a clean entry, and then you can clean it up. And there are more like also moving the URLs and reformat ISSN. But what's also interesting for me, it's rename PDFs to a given file format pattern. Assume you imported now your whole PDFs into JabRef, and if you have a collection for growing for dozens of years, you've got the PDF spread around your hard disk and renamed arbitrarily. And with this little help, it just gets consistent. It uses your BibTeX key and the title of the BibTeX entry as file name. And finally, this is here the expert thing. We've got formatters for all fields. And as example, we've got a pages formatter with normalized page numbers. Because in BibTeX, you need to have double dashes at the page numbers. And this formatter just fixes it. And for the date, in the bibliothek case, then the date is written in ISO format. For the month, this month normalization. And then for all text fields, we have the Unicode formatter, because BibTeX and Unicode is an issue, so we replace all Unicode stuff with the LaTeX and encoding. But we also have the vice versa thing, which means if you decide today, I want to move away from the old BibTeX thing, I want to move to BibLaTeX, we also have the LaTeX to Unicode converter built in, so you can just upgrade your bibliography to BibLaTeX. Okay. This was a glimpse on the features of JabRef. And now let's look into the thing, what are the properties of JabRef as project as a whole? Also what do we do? What are our core metrics? And it exists since nearly 20 years, starting in Java and still Java. But we update. We are currently at Java 21, which will be released in autumn. But we brought a fix into Java, so we use the newest JDK. We got 3,200 stars, and I hope that after the conference we got 3,300 stars, so that we keep up. And we've got nearly 90,000 commits, and I counted over 100 releases. And we've got, this is the interesting figure, we got 531 contributors in total, and from last year it were 100 less. And these contributors come from universities all over the world, which use JabRef as software engineering training object. And I will show later how this works. And then 6,000 closed pull requests, closed issues, and we are, the core group is 8 people. Running the project, but all of them in their free time somehow. So sometimes there's a delay in answering, but we try to keep up. And it's roughly 52,000 lines of code. And we also do have tests, because proper software engineering needs to have tests, and we also do have tests. Okay. Why positioning JabRef as software engineering training object? The observation I did is like, if an information science study program starts and the students are trained, they are trained using basic examples. They are trained to write proper algorithms, like how does a list work, how does a search properly work, and so on. And they have exercises there. And then if the study continues, they learn to work at more and more projects, but the study ends at large projects like distributed systems, workflow engines, Kubernetes something, whatever you name. But the missing thing is to work on a medium-sized project which is understandable and debuggable, where you can set breakpoints and you stop at a breakpoint, and where you also understand the context of the thing, where you concentrate on your software engineering skills, meaning specification, designing, writing tests, and coding. Also not only just to program something, but also the whole software engineering process around. And this is now where we position JabRef. Because it offers a real-world tooling and real-world code base. It's not an artificial program just crafted for software engineering. It's there and it's used by users. And what's also important for me, I see very good students around in their code, but and they also produce very good code as exercises. But after the exercise, the code is then thrown away because it was an exercise only. And with JabRef, this work is incorporated in a real-world product, so it's made sustainable. And as last thing, if a university takes part in this exercise thing, visibility, they can gain visibility and recognition for students and their groups. Okay. The thing is, how can a team working on the free time manage all these contributions? Because we can't have one-on-one sessions with students and saying, oh, what have you learned, what are your experience? How can we enable them for self-service of pick and choose of the issues? And our current solution is to not just to label issues as good first issues and say, let's go, that we tried in the last years, but now we came up with a more curated view of issues. And this is a link to the real GitHub issue, but they get more properties, and the properties are size of project. So if professors come in, okay, I'm in the third semester now, and I want to have something easy, then the recommendation is to have a small project, like integrate a check for predatory journals. Like if I've got a BibTeX database with some journals, and we know there are some fake journals out there, and they should be recognized, and this is some small thing. The other extreme would be a very large project, like rewrite of JabRef's entry editor. Because the entry editor is good enough, but there's so much room for improvement. But this is a large project to work on, but it's a good one for students because it's a focused thing, because the entry editor is one component of JabRef and you can just work on it. Then we also put main focus. Like, is it logic only with no UI, or is it logic and UI, or is it UI only? So that students can decide, okay, do I want to dive into this Java FX world, or do I want to sneak around and just do the normal coding? And then we also put a column like issue understanding effort, like how much mental energy you do need to understand the issue. Is it just, okay, drive-by thing, or do I need to understand something? And here's like how much we think one needs to do. Because the thing is, I always think it's easy, managing bibliographies is easy, and how hard can it be? But if you haven't worked for decades with literature, it's hard. So we could, the dates were the example before, and to explain someone, okay, there are different date formats and how to convert and how does BibLaTeX handle the dates and so on. It's hard, and then to say, okay, I want to have in JabRef the feature that it's handled properly. It's hard to get what a real user request is about. And then we have got the implementation effort where we say, okay, if you understood the whole thing, how long will it take? Because sometimes it's like it takes 2 days to understand, but then it's 3 lines of code. But you have to find these 3 lines of code to put. But even if it's only 3 lines of code, it's mostly like low implementation effort, and we've got also medium and large as possibilities. And finally, the testing effort, like, a proper software engineered product needs to have tests, and how much effort are the tests. Okay. So, now I showed you the tool in itself with some features. I showed you how to perform online searches, how to import PDFs, how to group, how to correct data, and how to enhance invisible things. And then what I did not show you, but I assume you know that you can share these text files using Git in a group. So if someone asks, how can I do collaborative work with JabRef, I say, okay, use Git. So, and that brings me to the end, and I'm open to questions.
Thank you. I have heard of JabRef from many years ago, but it always seemed like it would be more work to migrate. Looks like migration is simplified now. I do have one question I'm going to ask before I
Okay.
let the audience in on it. I believe I saw that in the last year you have 100 new contributors. How many of those are university folks? And are there particular professors that have adopted this year after year?
Also, university is a broad term, so I could say yes, because there are also PhD students coming in, and because they want to improve their daily use, but most of them are really students. And the professors making it year after year are the University of Basel here in Switzerland, and in Greece the professor teaching open source software development also uses it here year by year, and we got some of them listed in our page. Someone we have to ask students, hey, which course are you in, because it's like no activity, and then coming in, and then it lowers again. And it's usually at these courses, it's like semester starts, high activity, then you answer questions timely, and there's no activity, and then it's okay, now we've got 2 weeks until we for this final submission, and please help us. And these times we really try to guide even more, like even providing UML diagrams and so on, because the thing is, because this work should really be included, and if they have time, then the support is useful. But unfortunately, the sustainability of the persons themselves is difficult, because they come in and go out, because I think then like playing around with Kubernetes and Microsoft Azure and so on is then maybe more fascinating than development desktop tooling in Java. Yeah. But we still hope that some will be there, and we also currently have a contributor making more than 10 pull requests, which is very, very good to see.
Okay, well, we'll start with Boris. He always has a question.
Thank you. Absolutely great thing. I played with JabRef, but not much, so probably my question will be very stupid and ignorant. How scriptable is this thing? How easy it's to just get rid of UI and work with it? Okay, let me give you an example. I have 100 pages of PDF with about several hundred papers. I just want to go through all of them, get normalized BibTeX entries, get UIs of them, check, and so how easy I can put it into my scripts?
Okay. I got the answer is twofold. One answer is we have a CLI, but not covering your features, because it's very basic and not that maintained. And our future work is to do a proper CLI, because it's internal rework. But the other thing, I think you can guess the answer. It's open source, and I can show you the main class, and where you can start calling the things, and if you know one programming language, you know all of them, and then
So you showed that you can do pre-rendering of these BibTeX entries. Is this just implemented internally in the Java code, or do you actually parse and execute the BST?
I also need two answers. First of all, we pass it to the CSL processing library and do a CSL thing. We got an own customized rendering format, and we've got a BST VM implemented since 18 years. And even we modernized it to LR4, but we need someone connecting this BST VM code to the UI code somehow. The BST VM is around and covered with tests and really works well, but not connected to UI. But this is the next step. Is it this evening?
Well, thank you for a great talk. When you said it's been nearly 20 years, I was thinking, when did I first use JabRef? And I was like, oh yeah, 2004, I think. So I was wondering, so I'm my day job is I'm a chemist, so it's very sort of core physical science stuff in BibTech. And the features of JabRef, I mean, the GUI improvements have been very nice, and DOI imports have been very handy, but more or less it's worked well for me for 20 years nearly. Do you get a lot of feature requests that are still in sort of physical, natural sciences area, or are the features you're adding more towards humanities, or how would you describe them?
I would say it's diverse. One of our maintainers studies social sciences somehow, and he has very another view on things. But we also have mathematicians coming in, like with the strange symbols they use, as everything. And I would not see not perceived from the feature request some community being that dominant. But maybe he's the expert because normally they use the word thing and so on. And but we are keeping being asked when will be the word integration be ready. Yeah.
Yeah, your model of student submissions on your projects look quite interesting for general open source projects, not just JabRef. But I wonder, is there a tension between the student passing their assignments and you adapting the code into production? I mean, do you feel that pressure to import any code that you're submitted rather than fail the students? Because obviously they have I assume they have an assignment they have to kind of pass in a month or two.
Yeah, okay. It also depends on the professor, on the requirements. We've got one professor who said, I don't care if it's integrated, I just want to have them to have the experience, and to pass is to open a pull request. Which leads to the fact that one day before the final exam they submit it, we review it and nothing happens. Yeah, okay. But then internally we decide, is the code good enough to integrate, and we fix, and if it's not good enough, we just close and say sorry, and if you have more time, please come back. And the other thing is some really ask for integration, but then I've got, let's say 2 hearts in me. Like one is, okay, I want to be hard to them because they should learn to keep up with deadlines, because it can't be the case that they ask a question, we answer within 1 day, and they do nothing, and then they come back 2 weeks later and say, oh, tomorrow is my hand in. But on the other hand, I want to support them because I think they are relying on us as tool provider, and it's not that easy code base. So we try to support more than necessary. Also the UML diagrams are an example. Also why should I draw an UML diagram for a contributor in general? They should learn it, but do it to have them going in, and there are also private emails going in, oh, I've got which issue to choose, I need to pass my exam, and okay, now having seen one pull request of you, this could be the issue to go through. So we do both ways, but we are trying to first to be hard and to appear as hard and strict, so they do timely work.
Any more questions?
Hi, I'm Tom from Overleaf. Just a quick comment, maybe not a question, to the SharePoint. We know from experience that there is 2 types of people. People that think that Git is great, and people that don't want to use it. So I'm afraid that one of the points that will stop people from using JabRef is that you cannot do easy sharing of the things. So we know that people don't like Mendeley, for example, but they use it because they can share data over Mendeley very easily. So we know that this is a big pain point and really like a struggle for many people, and if you cannot solve it, then people will not use the product, I'm afraid.
Yeah, the thing is, I personally favor user experience very high, and I've got my personal view on user experience. One example, if you share your library using OneDrive, because or Google Drive, which is more accepted in the community, and one changes the file, and the other one has loaded the file in JabRef, JabRef pops up, the file change on this, do you want to import these entries? And I personally think this is more nagging. I think that I want to have some auto-synchronization going on and not, if I have a group of 20 persons and they work during the day and adding entries back and forth, I don't want to be asked each 5 minutes, do you want to resolve the conflicts? But on the other hand, this is a workaround. I would say you can easily share it. You can put your BIP file into a OneDrive, and you say that the PDF directory is the same directory as the BIP file, and then it's shared. But I know user experience is not 5 stars, it's maybe 3 stars. But thank you for the input.
Okay, thank you. Next up, we have Jan Sustek on generating documented source code blocks in TEC.
So is it working? 1, 2, 3, square root of 2. Okay, thank you. So first of all, I would like to thank the organizers for this great conference, and I'm happy to be here. Today I will tell you something about literate programming. I will start with explanation what it is, with some existing solutions, and then I will show you my solution of the problem, and finally I will give you some applications from real world. I used these applications in my previous jobs. So first let's start with motivation for you. I have 3 presents for you from our region in Czech Republic. So the person who will find a screenshot from the Word program in my slides, so just raise your hand and I will give you the present, and then I will give you 2 questions during the lecture, and this will be for another 2 presents. Now motivation for me. Suppose that you are writing some program or writing some package or generally doing some bigger thing. And in the program, you are writing 2 similar things on different places. So there are 2 possible approaches. The first approach is that you write everything twice. So you write the things on the places where they are. I prefer the dry approach. So if I need to write 2 similar things on different places, so I write some general definition and then apply the definition on the 2 places. Or I will write similar things in one place and then somehow move the things on the 2 places. So this is my approach. I prefer it. So let's look at it. Suppose that you are writing some program, and if the program is not quite trivial, so you need to write some documentation, some commentaries or comments or something. And if there is some idea behind the program, you need to write the documentation in a separate file. And again, there is some problem that if you modify the program, if you modify, okay, the winner is better. If you modify the program, modify the subprograms or functions, then you need to modify the program, and then you need to modify the documentation. So you are doing two things. Sorry. Yeah, Peter was first. Sorry. Yeah, you are doing two things. So I think it is better to write everything in one place and then generate separately the program and generate separately the documentation. In LaTeX, there is a tool called docstrip, and it works in the way that you are writing the documentation, and inside the documentation you have the lines of the program. And it is called docstrip. So when you process the source file by some program or some driver file, then the documentation will be stripped and you obtain the code of the program. The question is how it is done. So you have one file, the source file. It's usually with the suffix DTX. And you are writing documentation with the percent signs in the beginning of the line. Then you have the environment macro code. And inside this environment, you write the code. And this docstrip package has some added value. You can create some containers and write the code of some macro in the environment macro. You can trace all the changes that you made in the file during the time. Docstrip is often used for writing macro packages in LaTeX, therefore the environment is called macro. Yeah, here you can see the list of changes. So if you notify all the changes, then you can, using the docstrip, generate the index. And the changes are assigned to the macro. If it is denoted, they are assigned to the date of change or the version of the program. And there is one more added value that you can see all the macros which are used in the program, and you can see for each macro on which line the macro is defined and on which line the macro is used. Another solution, and in fact it was the first solution about the literate programming, is from Donald Knuth. And his idea was that when we are writing programs, so we should not write the program as a sequence of commands for the computer, but instead we should write programs as one person is talking to other person, explaining what the program should do. So Donald Knuth started to write the documentation, explaining each piece of the code, and because each piece of the code is quite long, so he used some blocks. And if we are inside the code, yeah, so we have here some block, and it is explained somewhere else. And then you tangle all the blocks together, and you obtain the generated program. Or you can use the program weave, and you obtain this documentation. Here it is the source code of TUG, of course, you can see it. And here's some block, it's block 1043. It is defined somewhere else in the documentation. You can see that it is defined in many blocks. So for instance, in section 1075, and inside this block you can use another block, and so on. So you can recursively use many levels of blocks. And here we can see the program, which is the output. Yeah, so the block 1075 is in yellow, and inside this block you have another block 1076, and so on and so on and so on. And now you can see the source code of the source code. So this is the original source code of TUG. I guess that many of you have seen it sometimes. So my question is, what is the name of this file? The colleague? Yeah.
There's only a single file, which is TUG.web.
Yes, definitely. TUG.web. Yeah, thank you. So the present for you. I will give it after the talk. So, okay. So now let's move to my solution. I just explained you that I do not prefer working in LaTeX. I prefer working in plain with the OpenMag macros. OpenMag, it is the package from Petr Olšák. It has similar functionality as LaTeX plus some packages, but the idea behind OpenMag is that the macros are not general. The macros do not know everything, but the macros are relatively simple, and they are easy to understand and easy to modify. And the task of the user is to modify the macros if he wants. So I work in this package, and in my solution I wrote some package which is doing similar thing as I showed you before. And I need to explain that my aim was not to write any package. My aim was not to write any general package, not at all. I was just doing tasks in my job. I was a data analyst, I was a teacher in the university, and I needed to program something. And then it happened that TUG and its macros were very useful tools for me. So, okay. So what I wanted to program, it's the first level, is to write some package called GenSRC, so generate source. So I want to define 3 macros. The first macro is file name. Okay, we need to write the name of the file which we want to generate, and then we want macros begin, source, and source, which just tells TUG that here the source code begins and here it ends. So that's all what I want. The question is, how many lines do we need to program it? So when, is it here? When we will process this file by TUG, we will obtain the documentation, you can see it, and also we will obtain file with the program. Really not so much lines of code are needed. Here I show you the macro backtt from OpenMag. This is macro for doing verbatim listings. So it's some 15 lines. And if I wanted, when I wanted to write macros for these verbatim listings plus exporting to the file, so I needed to change how much lines? Okay. I needed to change the name of the macros everywhere. So it's in fact no change. And then, of course, I needed to add one macro, it's getLine. So when we are in verbatim, we read each line, and what we do with this line, so the macro is called getLine, we read the argument until the end of line, and we print it. That's easy. And then we will write it to the source file. And that's all. And of course, we need one more line, which is the definition of the macro file name, which just opens the source file to export the source. So in total, I guess that there are 3 or 4 lines of new code. So by the way, here you can see the idea of OpenMag, that you just modify the existing code such that you need it. Okay, we can add some more hooks, no problem. So for instance, we can add, there was one hook in the beginning of the environment, so we add some other hook in the end of the environment. I was working with Python programming language. There was a problem that in the text editor, when I was doing the indentation, sometimes it was done with spaces, sometimes it was done with tabulators. In Python, not a good point. So, okay, one more line. I defined the tabulator to expand to a sequence of spaces. And Python was happy, and I was also happy. You can see that I'm not defining the macros directly, and I'm using some tricks with category codes. Of course, it is needed, because when I'm writing some program, the spaces are important. And when I am in TUG, so 2 spaces, it is the same as 1 space. So not good. And okay, when I'm writing some program, backslash is important. When I'm in TUG, backslash is doing something else. So therefore, really, we must be careful all the time about the category codes. Okay, so when I wanted to generate a source code together with the documentation, so what I was doing, I was writing everything in one place, and I defined 3 macros. Okay, in fact, only 2 macros, because and src, it is not a macro, it is just the delimiter of the macro back src. Okay, so this is the start of the of my package, and the next version of the package was using the blocks. This is not using blocks. So what about the blocks? So what I want is something like this. So I want to write the documentation using these several macros. So what are the differences? When I use macro back src with the angle brackets, so I am defining some block with some name. Then I can extend the block, so it is additive. And then when I do not use angle brackets, so I am writing to the program, and I can use the label which is defined somewhere else. And it is not shown here because I can show you only a few lines, but everything can be done recursively, and the blocks can be nested how many times you want. Yeah, here is the documentation which is obtained when we process the previous file by TUG. And so each block has some internal label and some formatted label, which is the documentation. Okay. And then, of course, the result is this. What you can mention is that the second and third lines are indented. How is it done? This is done because here on line form, I am inserting the block, and the block should be indented. So everything which is in the block is indented. I added this functionality to the package because I was writing in Python, and it was really necessary to do so. So in my solution, the indentation is locally additive. So how the package is implemented? Here I recall that in every line of the source code we are calling macro getLine. So originally it prints the line and saves it into the file. So now we should improve this macro getLine. So what this macro is doing, so when we are writing to the program, so it is just writing to the program, no problem. But when we are generating a block, so it must read everything, save it into some temporary file, and then in the second pass of TUG, we are reading the temporary file and export it to the resulting program. So here the macro should do what? It will print the line. It's nothing. Yeah. So just print the line, and then it will add to some macro content. So after the end of the block, we will have all the content of the block in macro content. And if we are using some nested blocks, so we add to macro content information that there is some block with some indentation and with some name, and we print the block. So this is the main difference which is needed. Okay, there are some technical details. That we need to check whether we are calling a block or not. So then how it works. So when we have the block, begin source and source with some internal label, with some line and some block. So after all, in the content, we have this information that there is some line and some block with some indentation, and we write to some temporary file the information that we are defining this block with this content. Okay. So this will be in the temporary file, and this will be loaded in the next pass of TUG. Okay, and now I have another question for you. It's a really technical question, so maybe nobody will answer. But I am using a colon here. So when I am storing information about one line, I have a colon in the beginning of the line. Why? Okay, that's right. Sorry.
You need a mic.
Sorry?
You need a mic.
No. Oh. Microphone.
No one up on the video here. I wondered, is it you're going to then, you want to be able to grab the second line, it could be all surrounded by braces, and if you don't have a token there, you can remove immediately after begin line, you'd lose the braces, and that could be a problem. So you just, the fact it's a colon isn't important, the fact it's a single token is important?
Yeah. Yes, yeah. Correct.
I would say it's because of indentation. After source begin line, since it's a control sequence, TUG is in skipping spaces mode, so you need to have some delimiter. So if second line started with spaces, it wouldn't eat the spaces.
Yeah, it's better, yeah. Definitely we need to keep all the spaces, and after reading token, yeah. Okay, but you have a present already. Yeah, so I will give it to the colleague, yeah. Okay, thank you. You're right, we must be careful with spaces, active characters, backslashes, pipes, and so on. Yeah. Okay. Okay, some technical things. So when we are reading this temporary file, so we just need to save the content of the block into TUG, into the memory, and then we have some control sequences which are storing this information, and then we are storing this information to the blue control sequence. And again, we must be very careful about everything, so therefore there are many expand afters. Sorry for it. So after these many expand afters, we have the content of this block, which is one line and which is the reference to another block. And when we will do everything recursively, it is done recursively because the expand processor of TUG is doing everything. So after all, we will have only macros one line with separate lines of the code, and this expands to write. In my implementation, I need many hooks. And again, this is because I needed it for my jobs. Okay, so the first hook is on the beginning of the block, beginning the source. This is done at the end. So this can be used, for instance, for graphical distinction of the source code. For instance, we can set a color here. DS, so this is a hook which is used when we are writing to the temporary file. Line hook, it is used sometimes. It is used, I think, in the beginning of every line of code. And right hook, it is used when we are writing to the final generated program. All of them are useful, and I will show you some applications. So I use this package for myself. So what programming language this is? This is BASIC. When I was starting programming many years ago, I was working on computer, Commodore 64, and it used BASIC. And later on, when I was teaching on university, so I found on the internet some emulator of the computer. And I was very happy that I can work with my computer again, so I wanted to program something. And this is a program for numerical mathematics. And I used it in my lessons because this program or this computer is very slow. It has a very small precision, very small resolution of the screen. So my numerical examples were quite visible here. When you are using modern numerical software, it is doing millions of operations every second, and the students will not learn anything from it. So this was quite useful in the lessons. And what is typical for programming in BASIC? So the program has no structure, definitely no structure. It is only the sequence of commands each line has some number, and you have many jumps to some other places. So how can BTech useful when generating this? So we can create the logical structure of the program using the blocks. So you are using the program in blocks and you are building the blocks together. And when you need to write the line numbers, so it is the hook at the beginning of the line when we are exporting it. And these numbers, so these are just cross-references. So you use the mechanism of cross-references as it is in OpenMac. So it is 2 lines of code. So in all, you are writing some 15 lines of hooks, and you are generating this code and this documentation. Notice that the numbers, of course, are different in the documentation than in the code. Of course, in the documentation, the lines are active, so you can click on it if you want. And after these 15 lines of hooks, you can write programs for computers made in 1980s. So you are writing in 2020s, in TUG, in program from 1980s, another program for a computer made in 1980s. Really, it was funny. I enjoyed it. The details about these hooks will be in my paper, so I will not show it here. Another application, I was working with a programming language which does not allow subprograms, which does not allow functions inside. So in using this, my package, so what is a subprogram? It is just a block. So when I wanted to call a subprogram, so I just called the block. I needed to set some input variables of the subprogram and output variables of the subprogram, and it was done. And the last application, last application which I will show to you is the output for several programming languages. So I needed to write a program which worked in several languages. Or particularly this was 2 dialects of the SQL language. So how to do this? Of course, these 2 languages must be very similar. And then you write some macros in TUG. Of course, in my environment, back SRC, you can use macros. You just set some active characters, and I just expand these macros in one language, and then I will run my TUG code for the second time with some other switch, and I will obtain this this file in second language. Okay, so the final words. What should I say? Thank you for your attention, and I wish you happy teching. Thank you.
Thank you. Well, I guess there's a question right away.
Yes. I understand that you use plain text rather than LaTeX, but for instance, if an author decided to write a textbook on programming and for practical reasons to use LaTeX for the document, would she still be able to integrate your results into the LaTeX document?
Yeah. It would not be so easy, but I think it is possible. So you have here some macros from OpenMac. Add to it one line. Okay, you can define the macros. Sometimes we are changing the fonts. Okay, so it can be done. Yes, I think it can be modified to run under LaTeX. We just need really to work with the fonts, which are totally different managed. And then we are working with expand processor. This is the same. Okay, here you can see the work with colors. Yeah, it will work. But it was not my aim to do so. So if somebody will want it, okay, you can write me an email and I can try it. But definitely this helped me very much in my job. For me, it was better to write a tool and then use the tool for something. It was better than to use something. Yeah, okay.
Am I correct in thinking that you haven't got a mechanism to write more than one file? So if you imagine a source where you actually wanted bits of two files close to each other because logically they're easier to document together, but you want them separate. Do you have a mechanism to do that?
Sorry, the end? It's quite
if you've got a file, if you want to separate, you can document them close together, but you want to generate two files at the same time. Do you have a mechanism to do that?
Yes, yes. I was working. I was doing some data analysis, and I was cleaning the data, and I was working with maybe 5 programs. So it was in 5 languages, 5 files, and really it was put together. You can just export to one file, some block, and export to some other file, some block, and then you are just defining the blocks. So it's one of the applications in my paper.
Thank you very much.
Okay. Yeah, okay, thank you.
Our next talk is by Barbara Beaton. Boris said that when he came to his first TUG meeting, he saw me. When I went to my first TUG meeting, I saw Barbara. Barbara will be talking about what every LaTeX newbie should know. Not that she expects that you are newbies, but you will meet many newbies if you're lucky. Barbara.
Thank you, Alan. First of all, do I have the little object to change? No. Good. Where did I get my questions? I have been following the Tech Stack Exchange forum, the question and answer forum, and so many questions come in that just, I'm afraid, make no sense to me. And so I've picked these questions because they just keep coming up more and more often, and they really should be things that people learn quickly so that they don't have to ask them. And I also was answering questions for a math publisher for many years. On Tech Stack Exchange, I've actually taken to gathering up what I think are good answers, and a lot of people have added to this list. There is a meta question called
often referenced questions that I've given the link to here, but this will be in my paper, and you can also see the slides online. And I recommend that if you have more questions about any of these items, that you go and look there, and maybe you can use some of the answers there when people ask you questions. And my final recommendation to start out is, don't be afraid to read the documentation. Even though David Carlisle says it causes problems, it's worth doing. Now, I have a few annoyances. That's not what I wanted to do. Okay, that's better. That people think something is different from what I think it is. So the first item here is, what is a template? A lot of people seem to think that this is, in LaTeX, is a document class. Well, that's not how I learn it. A template is actually, it's like a form. You have to fill it in. It just gives you a guidance on how things are organized. And if you think of it that way, you'll be much better off than if you think it's a document class. And I have two things to add here, because I've learned just recently, it just shows how long I've been around, that there are people who do not know what a command line is, and people who do not know what a log file is and what they're used for. So I will be adding those two terms to my vocabulary list. A command line is a line in a window that you can interact directly with the computer, tell it what to do, and interact. And it's useful to learn how to do this because it makes it possible interactively to, in some cases, make corrections. I'll go over this a little more later. And rather than pushing buttons or the images of buttons in an app, telling something specific on a command line, you can get precisely the result that you want, rather than depending on what somebody else has defined. A log file. A log file is the record kept by the program that tells you, in the case of TeX or LaTeX, exactly what files have been read in, what versions have been read in, various operations, and most importantly, the specifics of the errors that are found in your file. So learn to find a log file. If you're using an app, there will still be a log file. You may have to ask someone how to get to it, but learn where it is and use it. Okay. When you are telling TeX how to do something, you use commands interspersed with your text. I'm assuming you're creating a document. A command, by Donald Knuth calls them control sequences, and they're of two types. One is a control word, which consists of a backslash and any number of letters. It's easier if you keep them short, but you don't have to. But only the letters A to Z, upper and lower case, are used. And there is also a control symbol, and that consists of a backslash and one non-letter. Some of these are used to be able to print special characters that otherwise mean something to text, so that if you just put them in, they will do something rather than put something on your output, like the control percent sign will print a percent sign rather than saying that everything else on this line is to be ignored. The digits 0 to 9 are not typically defined by any package that I know, and they are left open for the use of the person who is creating the input. There's also a larger construct called an environment, which in LaTeX starts with begin and then embraces the name of the environment and ends with \n and it embraces the end of the environment. Now, the environment name in the begin and end commands has to be the same. If it's not matched or they are issued out of order, you will get an error. And it will be of the form shown here, like an exclamation point always indicates in the log file an error. And in this case, it's a LaTeX error, and it will say that the begin, and it will give the input line and say it does not match the end on another line. Now, for best practices, when you're defining commands, and it is useful to define commands when you are creating a document, it's best to use new command or new environment to create these, your commands. If you use def, it doesn't check to see whether this already exists. And if it does already exist, you can cause yourself a great deal of trouble because something that you expected to work, you may find later that it doesn't. And I show a bad example here that's actually happened to me. It wasn't exactly this, but it was very close, where someone had redefined a perfectly good \I, which ordinarily means this is an undotted I. And instead, when it got to the bibliography, there was something with an undotted I, and all of a sudden, there was a totally garbaged name. Authors don't like their names to be misspelled, especially not like this. So anyhow, if there is any question that this command may already exist, new command will check. It is possible to change the definition of something with renew command, but unless you already know exactly what already exists, don't use it. The next topic is, where are we? I'm sorry, I messed that up. Is where are you on your output page? I'm assuming that this is going to go ultimately to paper or to some flat surface like a screen. So there are three possible modes. There's vertical mode, which is where you start out at the beginning of a page or after a blank line. This is between paragraphs. And another way of ending a paragraph is an explicit par. And the par is actually built into some environments so that you will automatically get out of horizontal mode and back into vertical mode when some environments end. Now, horizontal mode is when you're within regular text in paragraphs or after indent or no indent or leave V mode, any of which takes you out of your beginning vertical mode into a paragraph. So within a paragraph or within a horizontal mode, multiple consecutive spaces, and they actually have to be consecutive. They can't have anything between them, are compressed into a single space. And an end of line, which doesn't show up explicitly, but it is treated as a space. And this can cause some problems, which I'll go into in a minute. But spaces at the beginning of an input line in your source file are ignored. So if you want to put extra spaces at the beginning of a line to make your source file easier for a person to read, that's quite possible. It will not have any effect on your output unless you happen to be in verbatim mode, which I'm not going to talk about. And the third mode is math mode, and that can be either within the text or in display. And because of it's possible to forget to match things like $signs, which establish your math mode, a blank line or a par within math mode is illegal and will result in an error message, which can be quite confusing. So we'll talk a little bit more here about spaces. I'm talking about spaces as they appear in the output. Text justifies text, which means that you have an even boundary, an even margin on either side. And spaces are adjusted so that the end of the line, all the lines end at the same space, at the same place. So if you don't want the spaces to be adjusted in their width, you want to set your text ragged right. But in US documents, and I claim that any kind of academic document or a document that contains a lot of abbreviations where you have extra periods, that you really want to leave the spacing so that the spaces after the ends of sentences are just a little wider than the spaces between words. You can turn this off with French spacing, and in fact, a number of document classes that are not intended to be in English do have this turned on so that all your spaces are the same width. And quite honestly, in that situation, I find it difficult to tell where the end of a sentence is if there are a lot of abbreviations within the paragraph. So here's a small example that shows the space, and it's not enormous difference, but it's enough to tell you that there is something different going on. If you want to make sure that your spaces are not the end of sentence, wide spaces after abbreviations, you just follow the period with a backslash space. This, in fact, is affected for any punctuation, but it's most obvious after periods. And you can see in the example that I have here, even in the input, which is in typewriter monospace mode, that the space is actually increased after the period. So after periods also, in abbreviations like page whatever, very often you don't want a line break or Dr. so-and-so. So use the little tilde instead of the space, and it will tie the two pieces together, and they will not break at the end of a line. If necessary, it will be brought over to the next line. Now, spaces can oh dear. No, I think I've got the wrong thing here. Yes. Okay. Spaces can be added by being a little bit careless if you're making definitions and you want your definitions to look pretty and readable in your source file. But if you leave spaces at the ends of lines, they don't get ignored, so that you will end up with extra spaces in your text and the output. That's not what you want. So this is a place where you make use of that % sign again, which is a character that begins a comment and says, everything else on this line is to be ignored. That is, unless the % sign has a backslash in front of it, in which case it will print in your output. But there are an awful lot of cases of questions on Text Stack Exchange that ask, where are these spaces coming from? So there are other places, there are other ways than definitions to get spaces in your output. And one of them is if you are adding a lot of index items into your document and you very neatly line them up on new lines, those spaces are no longer contiguous. They're no longer connected to one another, and they will each be interpreted as a space, and your spacing will go crazy in your output. So you want to use % signs there again to separate them. But do remember to just leave one space so that words will not be run together where you don't want them to be. So I also recently came across a situation where a space was caused by something that I wouldn't have guessed. And this was caused by something that was injected by a package. The person who was writing whatever it was wanted to highlight a single letter in the middle of a word by coloring it. And they used the T color box package and just colorized a single letter in the middle of the word. Well, it was nicely colored, but it had spaces around it. The problem in that case turned out to be the fact that there is a slight frame around the coloration definition, and that has to be redefined. And here's the nice use of renew command to redefine this without the separation between the what is being colorized and what surrounds it. So fbox sep is the equals 0 point is what is done to get rid of this space. But then also I found out that the coloration only covers the particular letter itself. And so I added a strut so that it would be a little more obvious. It's not very obvious all by itself, but by getting rid of the fbox sep and adding the strut into the definition of the color box, you get a nicely colorized letter that stands out in the middle of the word and doesn't make the word fall apart. Another thing that happens an awful lot is that paragraphs, certain things don't freeze until the paragraph ends. And here's an example where the size of the type is made too large and the baseline skip isn't frozen before the paragraph ends. It's a mess. And I guess I'm not going to be able to get through all of these, but I will just go through one of my favorite unfavorites, which is ending lines with double backslashes. There are places that this should be done, but ending a paragraph is not one of them. If a double backslash appears all by itself in vertical mode, this is between paragraphs, you'll get a LaTeX error, or you'll get warnings. So you really want to learn to use backslashes, double backslashes properly. And there are a few places where you use it for ending lines in poetry, or ending rows in a tabular environment, or separating lines in a multi-line math display. Those are all the places where you do want to use a double backslash. And how much more time have I got? 3 minutes. Okay, I'll go a little further. There are some things that really should be done only between paragraphs. Floats should ideally only be inserted between paragraphs. Commands for additional vertical space, you should use those between paragraphs. And in addition to the V-space, which does extra things that you may not be aware of, there's the original command V-skip, which you can give a dimension to, and it will say how much extra space to skip between paragraphs. But one place where you should not leave a paragraph break is before a block of display math, because usually the display is considered to be part of the preceding paragraph. And also, if you leave a blank line there that says this is a new paragraph, then if you're close to the bottom of a page, the block of math may just jump to the next page, and that isn't a good idea either. Well, it's not considered to be a good way to do something in a publication. So I'm running out of time here. Sometimes you want to make font changes. There are some that have limited scope, and these are usually commands that start with text and then a 2-letter command. And these will take their argument in braces after the command. The command EMPH for emphasize will not only change the text, but depending on what the condition of the text is before the command, it will set a word, an emphasized word, in italic if the text it's within is in upright. But if the text is already italic, as if it's in a theorem, for example, then it will set it upright. So persistent font changes are set with words like IT shape or BF series or SF family. If you want to learn exactly what those are, I advise you to look them up in a book, in a manual, because it's not necessarily obvious what they are. And I'm not going to try and go through that now. But these commands will just reset the style of the text, and if you don't have them properly closed, they will just happily go on until the end of your document. So you want to make sure that they are in an enclosed environment or explicitly close them somehow by changing the style back again. So I have one commercial break here. The LaTeX Companion 3rd edition really has an awful lot of information that you want to know. It's been very carefully put together, and I applaud its creator. So just try and skip through. Math is a closed environment, so anything you do within math will go away after you get out of math. But you do have to start and finish math explicitly, and if you don't, you will get an objection, either an error or a warning. If you get an error, you will probably cause many other errors that mean absolutely nothing. So when you fix your errors, what you want to do is you want to fix the first one and then rerun your compilation, because once the first error of that sort is corrected, all the others will go away magically, and you won't have to wonder what they are. So I guess that's the most important stuff I've got here. But my other most important item is, even though David Carlisle says things go wrong if you do it, do read the documentation. So if you have any questions.
Thank you. We have 1 minute until the coffee break.
Boris. Yeah. Barbara, there is an internet tradition of files which are called frequently asked questions. Should we start a file frequently made mistakes? Because a lot of you said is something which we saw again and again and again with submissions.
Well, that would be very nice, except for the format of the Stack Exchange forum is question and answer. So just giving a list of frequently made mistakes, unfortunately doesn't fit into their, into the way that they are set up. So if somebody can figure out how to do that, yes, you can do that. And I will help you fill it, but I don't know how to ask that question.
All right, thank you.
There's one more.
Thanks so much. I just wanted to comment that what you described, looking through the frequently asked questions in a Stack Exchange, is what one might call sort of a classic usability research method, right? You're looking at like things people usually kind of stumble across and don't know how to like proceed. And I think it's amazing that you've listed out the key concepts that people are, confused by, that seem unintuitive. And I wonder if there's more to do with that instead of just for teaching, like thinking about first concepts to build, but is there also a way in which we can think about how that feedback can help, us make some changes in maybe core LaTeX or the canonical editors? So one example I'm thinking of is, well, if people don't understand document classes, but they do understand templates, or they confuse them with templates the whole time, would it make sense to just kind of take that and say, well, there is a article template and there is a memoir template, and people can, you know, think about it in those terms. I'm not sure exactly what I'm getting at, but like, is there like a vanilla version that we can make to make it easier for those people to start their tech journeys? Thanks.
Oh, I'm sure that it could be done. I did it for the 3 document classes that the American Math Society provides. But, you know, not everybody is issuing documents there.
Okay. The coffee is getting cold.
I'm sorry.
So, 1/2 hour, 11:15. Thank you. will be taken after lunch before the afternoon sessions begin. And we will gather here. I'll go up in the organ loft and take a picture looking down at everyone. They tell us that works very well. We'll see. If it doesn't work out, we'll have more opportunities. Okay, the other thing is, for the speakers, if you roam around the stage, stay away from the loudspeakers, because you get the feedback. So use the middle of the stage only, please. Okay, our first talk is by Martin Ruckert, News from the Hint Project. And I'll just say that as I read the preprint, I saw a blast from the past. PK fonts. Who'd have thought?
Okay. First slide already on. I think the microphone is on too. I'm Martin Ruckert. Hello. I will report on the progress made in the HINT project over the past 2 years. You shouldn't expect too much because I have a full-time teaching job on the side, but I will go in retirement in fall. But it's an open question whether that will improve the situation. So, okay. PK fonts. One problem I worked on was displaying the glyphs. The first viewers that I had for the HINT viewer was Android. And Android mobile devices usually have a very high resolution, often 300 dots per inch or more. So good rendering of the glyphs was not really an issue. This changed when I implemented the HINT viewer for Windows and for Linux, because on a large computer monitor, the resolution is often below 100 dots per inch, and good rendering becomes really an issue. The usual rendering procedure is outlined on this slide, and I started with PK fonts, and PK fonts define black and white bitmaps at a fixed resolution. For HINT, for high-tech, which generates the HINT files, the default is 600 dots per inch. And the graphics card will render a pixel on the screen by interpolating the pixels in the bitmap and thereby creating gray values for each pixel along the border. Now, on a high-resolution monitor, lots of pixels are inside the outlines, inside the glyph, and so they are black. But on a low-resolution monitor, only a few pixels are completely inside, and most pixels are along the border. So you get lots of pixels with various shades of light gray. You see something like this here, and this needs improvement. So the obvious improvement were, of course, outline fonts, and I use now PostScript Type 1 outline fonts. And I render them using the free Type 2 library. This process produces gray value bitmaps that are optimized for the actual resolution of the screen. You see the view got much more defined than it was before. And now we can look at the first video clip. Hope that works. Okay. We will look at a demo that shows a 10-point computer modern Roman font on a 141 dot per inch screen, and there is also a magnifier window to the right that shows a cutout 8 times magnified, and we have left the Type 1 font and on the right the PK font. Now, let's see. Okay, here you see the font. And we see the differences between this is on one side the PK font, and on the other one and while scaling, I don't re-render the outline fonts, so they show pixels. But when I stop rendering, I re-render, and then they get more defined. So this is the type 1 font, and this is the PK font. So you see the differences. The differences are more problematic with small fonts. So when I change to smaller fonts, observe the initial M and the first vertical stroke, it disappears and comes back. And when I re-render, the outline font is clearly more readable than the PK font. So that was the first improvement here. Thank you. The next improvement was rounding of the positions of the glyph. And we see the same layout and see how the rounding of glyphs in vertical and horizontal size affects the visibility of the glyphs. Can we have the second video clip? Okay, it's a 10-point, a 7-point, and a 5-point computer modern Roman text. Same setup with a magnifier. You have one word here, and you can switch between. I change the size of the window, and it changes the margins, and so the things move. And you see the L of how it gets rendered in different ways, and so the movement appears to be smooth over the pixel grid. Now I switch on the vertical rounding, and the horizontal rule get more defined. And when I switch to horizontal rounding, the vertical strokes get more defined. And of course, best is if I switch on both roundings, and I also switch off the interpolation. Now, this is now the effect. You get clearly more defined. And that's the effect of rounding the glyphs means the intercharacter spacing wobbles. It gets very unsightly, and the vertical line spacing also wobbles by pixel by pixel, which is less distracting than the changing intercharacter spaces. But that's, well, a consequence of rounding to pixel positions for small fonts, because the inter-character distance here is only 1 or 2 pixels. So rounding means you increase the spacing by 50% or decrease it by 50%, from 2 pixels to 3 pixels back to 1 pixel. So this is the disadvantage for getting good glyphs. What I have now is a threshold in the viewer. When the font gets too small, I start rounding the glyphs to pixel positions. If you have big fonts, then that is not necessary. Because if you have a character distance of maybe 10 pixels, it really doesn't matter if you have half a pixel more or less. But if the character distance is very small, you want readability. Okay, then let's look at the next thing I changed. I implemented links, labels, and outlines, and thanks to Ulrike, there is a growing LaTeX support for these features. And while we learned to navigate real books already in school, this skill, how to navigate books, is almost useless when it comes to big electronic books. So we actually need links and labels for navigating books, big documents. And there is one big difference between going to a label in a PDF file. You just need to switch to the right page. Whereas in a hint file, there are no pages. You have a label somewhere in your document, and you have to generate the right page at the given space in your window for that label. So you pick some text preceding the label and some text after the label and try to get a nice page with 2 good page breaks that fits around that label. So that's an entirely different program. We have to generate the target page. Okay, let's look at video clip number 3. We look first at TECH, the program, Don and Knut's TECH file, generated by CWeave, the current CWeave that generates links and labels. We look at paging and look at the home page. Well, here is the CTECH file. I'll open it. Well, I make it a bit bigger so that you can read it on the beamer and increase the font size. Okay. This is the Windows version, which is mouse-oriented, so you can page forward. And there is a home button to the right that brings you to a user-defined home page. Here it's a table of content, and you pick a section, 172, click it, and it brings you to the right section. If you don't want to use the home page, you can also open outline window. It's an operating system-generated window where you have the major sections, the start sections, and you can click on them. So here's the introduction. This is a table of content. And you can go down to the index, go to the next page here, pick some section 1, 2, 3, 5, and it brings you to the right section. You can follow the links here, brings you to another section. There are also sections that you can use. You can go back using this link. So you can navigate the document using these links. I show you another example, which is a document specifying the hint file format, and it uses a different design. It's also a literal program, but it has a more traditional table of contents, and there are no page numbers here. But it still gets you somehow to the right section. The outline window has a hierarchy, so you can hide subsections, like 4.8. You can open and close the major sections. As usual, go to the labels. There's also an index here. And as usual, indexes display page numbers. Here we have, again, these little arrows, because I don't have page numbers. And you can go to the place where aux name is used, and you get a page that just starts somewhere and ends somewhere where the system thinks that's a good place for this label. So it starts somewhere, and it shows the use of this aux name. This is how links and labels are implemented now. Next topic that I worked on, oops, here. No, okay. We need to, this is still the video clip. I think I need to get back to the slides. Okay. Is it wrong? No. Can we go to the next slide somehow? This doesn't seem to work. This is a clip that we have just seen. I would like. Okay. These are the slides. Okay. Okay. This is the next topic. Macros that cope with variable page sizes. And I have two examples. The first example is centering text. Two ways, one using the centerline macro and the other one is using left and right skip. Can we see clip number 4? Okay. The centerline macro is just a horizontal box with fill glue, and there's no line breaking in a horizontal box. So it's better to use a vertical box. This is the output, and here is the source. So it's just a center line. And in the vertical box, I use a right and left skip that can grow, and a fixed inter-character space. So if I change the window size, the center line starts to stick out, whereas the vertical box, the paragraph, is just reformatted. Okay. So the vertical box just performs better than a horizontal box when it comes to changing page sizes. Okay. Now, the next clip shows a more advanced example where we have side-by-side a left adjusted part, a center part, and a right text. Can we see the next video clip? Okay. Again, we try using a horizontal box and fill glue, and the alternative is a VTop box. And here is the source code. The fill glue will just make sure that the glue on both sides of the center text is of equal size, but it does not really center, except, of course, if you ignore the size of the left and the right text. Then the middle text gets centered. Here we have 3 boxes with a fixed inter-character glue and variable amounts of right skip and right and left skip, or only left skip. These are the differences. And we have just left skipped in the right one. Now let's look at the output. Okay. You see in the first 3 lines that only the third line really centers the center text, but ignoring the size of the left and right text will have its own consequences, which you will see in a moment. Well, the paragraph breaking makes sure that the middle text gets broken. And of course, if you ignore the size of left and right text, it's ignored. That's what it does. So this is an open field of designing macros that work well with variable page sizes. When you make something smaller, the title, for instance, which is centered, should somehow adapt to the width of the page. Next topic. Can I get back to the slides, please? This is the clip again. I don't want. Can you stop the clip? Okay. This is the slide. Okay. Well, no, this is not right. Yeah, okay. Then I try to get that forward. Okay. There is also a new feature that converts a hint document to plain text strings. And this feature is now used for generating the outlines, because the operating system just wants plain ASCII text for the outlines, and we have seen that already. And the other use is searching for strings, because you type in a search string, and that's usually plain text, and you want to find something in a TUG document. And there are a couple of problems. Ligatures are a problem when you do searching. Hyphenation and page and line breaks are a problem, and the difference between a glue and a kern is also a problem. Let's look at clip number 6. This is not the right clip, I think. This should be clip number 6. Can you stop this one and play clip number 6? Okay. This is the last clip, so. Okay. Good. Yeah, character encoding is also a problem, but it's not yet implemented using reasonable character. Okay, I open a document, go to the search input field, and I search the word difficulty. And I click here, and it finds the word in spite of a hyphen in it, and a line break, and interline glue, and an FI ligature on the second line. So this works quite well. Let's look at a different document and search for TUG. Works nice. Let's search for latex. So in LA, it finds the LA, but when you type the T, it no longer finds it because there's a glue between the A and the T, not a kern. And so you need to type LA space TUG to find it. Maybe that can change in the future. Let's look at searching for mathematics like A1. You see that the found string is in red, greater x to n. That works all okay. It finds the text. And let's try, well, still 2n, so it finds that formula. Let's look at x minus 3. The x is found, but when you type in the minus, it's not longer found. I suspect the minus is implemented as a horizontal rule. So no chance of finding it here, because it's not there as a character. Or it's in a different font. Yeah, that's one of the problems that we have here. Okay, so there is still something to do. Thank you, and I'm coming to the end. I implemented viewers for all major operating systems that share the same backend and almost the same front end, and there's some small code in between. The smallest is the Linux system. That's just 600 lines of code. And there is a page with resources where you can look at the different things. And I'm available for questions. Thank you.
Do you plan to support bidirectional typesetting? So having left to right text versus right to left, or even top to bottom, as in some Japanese texts?
This is a research project, and I have very limited resources. So yes, it would be possible to support bidirectional typesetting, but it's mainly a problem of the TUG engine that generates these files. The viewers have no idea of what they render. They just take the information of boxes and glues and whatever is there and render it. So they have no reading direction. The viewer would be the same, I suspect, but the TUG engine needs to be able to do that. It would also be possible to take a TUG engine that knows how to do that, like LuaTeX or Xetech, and add a hint backend to it. That would be probably the better solution.
I'm interested in your conversion from the hint file to plain text. Do you create a canonical representation that you search for? For example, the hyphenation. A hyphen at the end of a line may be part of a hyphenation character, or it may be part of actual the word. Do you produce some kind of canonical intermediate representation where you search in, or do you take several variations where you search for?
The page builder builds a tree of boxes, glues, and these things, and I search basically that infrastructure, the same structure that I display. For ignoring hyphens, when I do the hyphenation, I leave a mark of where text stops and the pre and the post things get included and where it continues.
Oh yeah.
So I can skip that. Like with ligatures, where you have also the original text that was replaced, and so I can go through that ligature text when I search.
So I've got a question here from the online chat I'm going to relay from Werner Lemberg. He says, why do you reinvent the wheel with font position rounding instead of using, say, free type in auto hinting mode, which automatically does the right thing? The auto hinter is sub-pixel rendering mode, providing quite good results for exactly this type of problem.
You mean the sub-pixel, you are interested in the sub-pixel rendering?
Not yet. He asked about, he said that free types auto hinting mode has sub-pixel rendering is what he asked about.
I wouldn't know how to answer that question yet. Maybe we can discuss it afterwards on a one-by-one basis.
Do you already looking to get this hint viewer ready for ebook readers? This would be really nice.
That was one of my first things that I did. I contacted the main manufacturers of ebook readers, and there was no interest in anything besides the formats they have already. But that was the starting point. I was very unsatisfied with the out of the computer programming, a mixed supplement and the ebook that came out for it. That was a nightmare. So I started this project.
Thank you very much. Switch to turn on also. For some reason, the batteries never tell you before they wear out. Our next talk by Dennis Mueller, an HTML CSS schema for tech whatsits.
That's the old name.
That's the old name, all right.
In the meantime, I learned that what's it means something different, so I changed it.
I was going to say, that sounded very unusual.
Right. First of all, thank you very much to the organizers for accommodating me in the schedule. Today is sandwiched between my girlfriend's birthday yesterday and a gig with my band near Munich tomorrow. So I'm here today only, which means if any one of you wants to talk to me, make sure that you do that today. Yo. There we go. So, to some extent, the title of the talk is now a bit of a misnomer. Both the talk and the paper are going to be about RustTech. The idea of RustTech is that it's a tech engine implemented in Rust that converts text sources to HTML. I say it's a misnomer because in the paper I actually describe all of the CSS and HTML schema that RustTech uses. In this talk, I'm not going to do that because that would be really boring. Instead, I'm going to spend the talk basically showing you some things and justifying my life choices, I guess. So the core idea behind RustTech is that unlike most other conversion engines, it tries not to implement any dedicated support for specific LaTeX macros or packages or so on. Instead, it tries to behave as closely to the PDF LaTeX core engine as possible, producing the same kind of boxes as output, and then trying to map those primitive boxes directly to HTML nodes, usually diffs with some CSS annotations. Ideally, that means that given any arbitrary text file which actually compiles without errors in PDF LaTeX, it should also compile with RustTech. And ideally, it should also, the resulting HTML should look reasonably similar to what you would expect from what the PDF looks like. So in that sense, you can see the whole thing as kind of an experiment. Is that even possible, given the very different box models that TUG use and that HTML, CSS use? Spoiler alert, the answer is surprisingly well, of course, with a couple of caveats. So first justification, why do we even need yet another text to HTML converter? There are already dozens out there. And to justify that, I have to go into details on our use case. I gave a talk at last year's TUG about the STEC package, so I'm just going to very briefly skim what we're trying to do. The idea of STEC is by the head of our research group and my former PhD advisor, Michael Kohlhase, which I think some of you might know personally. And the idea is that we can represent both the layout of a document, primarily targeted mathematical documents, and the flexiformal semantics of the various statements in that document in the same document format, i.e. in TeX. Then ideally, what that allows for is that we both have a human-oriented document and a machine-oriented representation of the semantics, which we then can have various knowledge management techniques act on for additional services, such as disambiguating symbols, interlinking them, linking them to definitions, giving you exercises, examples for various things, up to type checking, or in some ideal world, even interactive theorem proving at some point. And the way that that works is that instead of using the usual LaTeX macros that you would use to typeset some mathematical formula, instead you import some module that gives you declarations that correspond to the various concepts that you use in there. And then you use semantic macros like this \series. And that way, you get the same output, but now the system basically knows, oh, this sum underscore I equals 0 represents a series over some sequence, and you can declare the sequence as a variable or as a constant sequence, and so on and so forth. So you get the same output, but now you have something that is machine actionable. And of course, the whole thing is highly modular. We collect definitions and concepts declarations in modules, which in turn import other modules, which in turn import other modules, and so on and so forth. So basically, modules act like LaTeX packages, but for mathematical concepts rather than typesetting macros. And the way that that worked pre-2021, roughly, was that in order to get that to work with PDF LaTeX, you needed to use dedicated document classes. You had to set various system parameters of TeX in the first place, which was always a pain if you had anyone who just wanted to start working with that. Then that you needed additional software even to get it to work with PDF LaTeX, just to like be able to resolve all of the like module locations where LaTeX can find them and so on and so forth. And then you get PDF, and that PDF is just human-oriented. And then additionally, if you want to have something machine-oriented, you have to use a LaTeX ML plugin, which only worked for a very outdated version of LaTeX ML, so you had to find that and then install the plugin, and then that generates OnDoc, a representation format also developed by Michael Kohlhase that can actually represent the formal semantics of statements, with which a priori you can't do anything. If you want to do something with that, you have to use an additional piece of software called MMT, which then imports that. So the whole tool chain was utterly insane. It was barely usable by anyone except for Michael himself. Indeed, I myself never actually got it to work. So by 2017 already, that was practically unusable. And then after I finished my dissertation, which was in 2019, after a brief stint, I went up to Michael and basically said, hey, I love this idea, this is awesome, this is perfect, but nobody can use it, we can do better. So what we wanted instead is have a single LaTeX package that you can just import anywhere in books, in slides, lecture notes, whatever, just a drop-in usual document package. You should not need any additional software to have it run with PDF LaTeX, because I want to be able to write papers with that. And if you write papers, you have to at some point submit your sources, and then if you need shell escape or additional software, that just doesn't work. And of course, instead of producing separately PDF-oriented for humans and OnDoc-oriented for machines, why don't we use the same representation format for both? And then the idea was, instead of converting to OnDoc directly, we would just convert to HTML and store all of the semantic information that we're interested in there as annotations on the DOM. And if you do that, you don't just have the human-oriented version and the machine-oriented version, but you have both in the same format, which also allows you to then inject additional services via JavaScript into the HTML that actually act on the semantics. And that was STEC 3, and that's what I gave a talk on last year. So what does that mean? That means we need a text to HTML converter that ideally can deal with arbitrary LaTeX, where by deal I mean it should yield HTML that looks reasonably similar to what you would expect. It needs to be able to preserve the semantic information that we compute basically in the STEC package, and then that should survive the conversion to HTML process. And since our expected corpus of STEC documents is highly heterogeneous, it should be virtually guaranteed that it succeeds for any valid LaTeX file. Even if like the output might look broken, if the conversion succeeds in the sense of that it does not fail, at least we have a document where we can get at the semantic information, even if it looks kind of broken. And also at that point, we had a new research project approved, the Volker-E project, whose goal it is to improve college-level education using AI techniques, whereby AI, we usually mean good old-fashioned symbolic AI. And of course, for that, we wanted to use STEC. And if we're now planning to rewrite STEC basically completely, then we better do that now, and then time is of the essence. And it turns out that none of the existing text to HTML converter were able to do all of the things that we needed it to do. At that point, a couple of weeks ago, I figured let's do some statistics. So I picked my directory on my hard drive where I have all of my LaTeX files. I'm sort of a data messy, so I still have like old homework assignments from college and all of that. Exclude all of the stuff that actually uses STEC, because STEC does unspeakable things, which I can not reasonably expect any converter to deal with. And then see on how many of those documents the converters actually succeed. And it turns out, if I were to like actually write down the statistics here, that would be highly misleading. misleading because with Pandoc, I basically didn't get anything to work at all, which I'm almost sure needs to be my fault. For Tech4HT, it worked reasonably well, so I got 60%. And for LaTeX ML, the timing was just really bad because the current version of LaTeX ML does not work with the current version of TeX as soon as XPL3 is involved. I know that that is a temporal problem. I know that Bruce Miller is heavily working on fixing that, so yeah, that makes it a bit difficult. But let's compare. Anyway, here's one document that I managed to get to work with PDF LaTeX, RustTeX, Tech4HT, and LaTeX ML. My undergraduate thesis, actually. So this is the output that you get from Tech4HT. Looks reasonably well, but one thing that you might notice is I have a theorem here, and that theorem has a proof, and that proof has 3 steps, and then I have a list that starts with proof of 1. And then in that list, I have a second list that starts with idempotence and absorption. And what I get out of Tech4HT is just bullet points. That is kind of a problem in this particular setting because like the listing names actually do have important information. If I do the same thing with LaTeX ML, the first thing that I notice is that it's not usable immediately just because we live in an age of like 8K screens. Right, so you get this weird centered thing which is somewhere after the end of the line and all of that. But both for Tech4HT and LaTeX ML, before I'm being accused of being unfair, the good thing about both of those systems is that you can easily fix that. You can just add your own CSS and make it look nice. So let's take the LaTeX ML output, add a max width, and while we're at it, also change the fonts because I don't like the standard fonts. In particular, the ones for math I don't really like, so let's just switch both to Latin Modern, and ta-da. That looks nice, if it works. In particular, my claim would be that LaTeX ML has probably the best math ML output you could possibly wish for, so that's nice. So with some massaging, which you can do, you get really nice documents, and this is what it looks like with RustTeX, basically the exact same thing as the PDF. In fact, recently my professor complained that whenever I show him screenshots, he can't tell anymore whether it's the PDF or the HTML, which is often the case, but of course you can find scenarios where that entirely breaks. Yes, sorry? Sorry? No, the links? There are links there, but they're highlighted exactly as they would be by PDF LaTeX. These red boxes that you get are inserted by the PDF viewer, actually. So therefore, you don't get them over here. But they are links. You can click on them and jump to the right position. OK, so for relatively reasonably standard LaTeX documents, both Tech4HT and LaTeX ML work really nice, especially you can add your own CSS, which is an advantage on its own. With RustTeX, you can't do that. So what happens if we like go down a couple of levels? Here's a ridiculous example of what you can do in TeX just by using hboxes with various parameters. So you can do these things on the left just by like adding widths and twos and heights and depths and all of that. RustTeX reasonably tries to do the same thing. In both Tech4HT and LaTeX ML, you lose a lot of information. What is the cost of that? Well, the cost of that is that this is what the HTML looks like that RustTeX outputs. It basically looks like the kind of HTML that you get if you use like a modern web framework like React or whatever. Here, similar thing, what you can do with like various types of V-boxes. You can like do really weird alignments of those. RustTeX, again, tries to mimic that. LaTeX ML at least realizes that this is a V-box, so it like puts line breaks between the things. Tech4HT, just plain thing. And a similar thing with like fills and skips and these kinds of things. For some reason, Tech4HT here also does the color wrong, but that's probably just a minor issue. So you might think, why do we care about like hboxes and vboxes? My claim is, to some extent, you should, but that's not a fault of Tech4T or LaTeX ML, because both of those systems have very clear use cases. And I think the examples that I just showed you kind of demonstrate what the point is. With both Tech4HT as well as with LaTeX ML, you can generate relatively simple, nicely customizable HTML that mimics what the system thinks you intended to do based on your usage of tech macros. So they focus on those kinds of macros and packages where there is a clear notion of what the expected HTML output even is. Try to keep the HTML plain and simple so that you can like customize it yourself. And that's all perfectly valid. But the result is that both of those engines can be easily tripped up if they encounter unexpected macros, if they use packages that are squarely outside of like a certain comfort zone, to call it like that. And in order to achieve these, they often tend to neglect in-depth support for low-level tech primitives, where in-depth support to some extent would entail things like actually putting fixed dimensions in your HTML, which you also don't want to do if you want to have like nice plain HTML, in particular if it's supposed to be responsive. That is very much contrary to common practice. If you think about how most LaTeX users actually use LaTeX, I would claim there's almost no one who does not have like a single tech file with just collections of macro definitions that they copy and pasted from friends, colleagues, Stack Overflow, by now probably ChatGPT, with a bunch of packages that you just have in there because you have them in there, which you then reuse over and over again. I mean, you guys probably don't because you know how tech works, but I would claim the average LaTeX user works precisely like that. And that means if you just take an average LaTeX file that works perfectly fine with PDF LaTeX and you feed it into one of those engines, it's quite likely that something is going to happen that makes the thing fresh. Right. So, and the idea behind Rustech, therefore, was if we actually actively try to avoid providing any kind of special support for LaTeX macros and instead try to do everything with the primitives, then we can achieve the goals that we needed to achieve, i.e. it should ideally compile, if it compiles with PDF LaTeX, it should compile with Rustech. It should look somewhat similar as the PDF is expected, but of course at the cost of document semantics. So basically Rustech generated HTML is just deeply nested diffs everywhere with CSS. If you're interested in the CSS schema, see the accompanying paper. Now to show you some examples. That should not be too surprising. You've seen lists before, also section headers. So far, this is just basically what you would expect if you like put a document like that into PDF LaTeX. This is the PDF that you get. This is the HTML that you get with Rustech. For something more interesting, here's a table inside an MD framed environment where the MD framed environment uses vertical and horizontal rules to actually construct a box. Rustech tries to perfectly mimic that, and that works reasonably fine. The most dire thing that I've noticed so far happening is that occasionally the box is a bit too high. That's the kind of thing that I personally can live with. Yeah, but of course that also means in this case responsiveness with respect to the HTML is probably going to be somewhat out of the window. If you now scale this down to too much, text will just protrude out of the box. But if you don't do that, if you just look at it in a browser, it's basically going to look exactly like the PDF. Listings. I have no idea how listings internally works, and I don't need to. If I do begin listings, it will do some kind of magic. Ultimately, it produces boxes. I just translate those boxes to CSS, and I get the basically exact kind of thing that I get in there. In particularly with these like gray bars, which are probably difficult to see depending on what kind of contrast you have. Yeah. Bibliographies, I don't need to have any kind of process to mimic BibTeX. If you compile it with PDF LaTeX, you get your BBL file. If you then compile it with Rustech, you get your bibliography, exactly how it should be. One personal highlight of mine, I re-implemented the whole, oh yeah, sorry?
Can you go back one slide?
Sure.
Between the PDF and the Rustech version, there is a case change in the word visited inside parentheses.
Whoa! True! I have no idea how that happened. That is even weirder. My algorithm doesn't do anything with BibTeX in particular. So there must be a tech reason and probably an associated bug somewhere, probably something like UC characters or lowercase characters or something like that. That might be a bug, but I have no idea. It also might be just a difference between versions, like the PDF I've had lying around since like 2019 now. The Rust-Text generated is relatively new. There might be some discrepancy like that. I honestly can't explain how that happened, but good catch. Yeah, thank you. One personal highlight, I was re-implementing this whole CSS schema a couple of months ago, specifically for writing the paper. And one colleague of mine, who we now forced to use STEC, at some point complained, hey, I'm doing this algorithm and it looks horrible. So I figured, okay, let's see what does my new CSS schema do with it, and it popped out exactly like that. So that was a success for me personally. T-color boxes generally also work really nicely. Again, here responsiveness is basically out of the window because, as it turns out, apparently T-color box uses PGF in the background, and PGF is converted to SVG. And of course, you can like scale SVG in theory, but you can't scale it such that it like perfectly adapts to however big like your text is or whatever. Also one thing, the box at the end of the proof is not where it's supposed to be. Why? Because HTML and CSS don't have a thing like put infinitely growable space here. So there's no current solution that I can think of how to deal with that. If any one of you knows CSS, I don't. Great, talk to me. I'm very open to ideas. I want to make this look as nice as humanly possible. A nice paper that was also published a couple of months ago, Every Author is First Author, where they finally solved the problem of what should the author order be in some paper. Their solution was, let's just print all of the name on top of each other, and described how to do that in both TeX and HTML. I love this paper. I ran it through Rust-Tex, and it looks exactly as it's supposed to be. So that also a personal highlight of mine. And why we're doing this whole thing, this is what the average STEC document looks like. This is one of Michael's lecture notes. He usually uses the slides that he does in his lectures and intersperses them with like explanatory text. And basically everything you see here is outsourced into individual files so that you can properly reuse them. So you probably have like this introductory text and the slide in one file, then the next paragraph you have in a different file, and all of the definitions and the axioms are also different files and they're included. And of course, if we do this kind of thing and we generate HTML anyway, then we want to not have to recompile all of the included stuff. Instead, we want to compile everything individually and then dynamically insert them into the HTML, which means to some extent, our documents need to be responsive. And they are. This is the HTML. Looks exactly how it should be. And now, of course, what you can do with the whole ST system is you can do things like hover over symbols, and it will show you the definition, and you can do that recursively. And yeah. So conclusion, there's still lots of work to do. Some things look really ugly. It's by now relatively difficult to find those. But if you want to look around, this courses.volki.fau.de link is where you can find our course portal with all of the lecture notes. The other URL is where you can find all of our stuff. And by that, I'm basically finished. Thank you.
Thank you.
Thanks. Yeah, on your nested divs, so the usual advice for people writing HTML is kind of not to do that. I mean, how is your view to like accessibility? We had a workshop on tagging yesterday. I mean, how is a screen reader, if everything's a nested div with CSS, do you mark up headings? I mean, all the usual document structure things, are they gone? internally? And
They
if
are largely gone, yes.
Yeah, that's
so
going to be a problem.
accessibility
It's going to be a problem for the screen reader.
Yes, I haven't tried it yet. If there's something we can do about that, I'm very keen on having that work. With respect to MathML, we've now added macros that allow you to annotate it with MathML intent, which is like the accessibility feature of MathML 4. So in that direction, we have something. With respect to generated, the rest of the HTML, I would need to grab someone who actually knows all of the accessibility features and help me with that. For now, probably, sorry, no, but yeah, it's on my plate.
I wanted to ask how is your support for matrix and mass mode and like more complicated two-dimensional formulas with arrows and things like?
That should work relatively fine. I'm largely following the quote-unquote default mode to map take things to MathML. It might look a bit more ugly because if you do it really on the level of primitives, then you very often escape from MathML to HTML back to MathML. So the trees might look ugly, but things like matrices are not a problem. It's just an M table. Right?
Okay, cool. Thank you.
So I know of all of your efforts with these unpronounceable backends for archive to convert that to something that is browsable.
That is not me.
That is not me, but it's also by Michael Kohlhase.
Not really. It's by the LaTeX-ML people, which is Bruce Miller and Dayan Ginneff. And Dayan Ginneff is a PhD student of Michael's still. So there's some association there, but LaTeX-ML is a different piece of software.
Because I was thinking whether Rustec would finally be the silver bullet to do this.
You can already do this. It's called R5ML. So if you go on archive.org and you just put any paper and you replace the X in the URL in archive by a 5, you get the HTML5 version generated by LaTeX.
Unfortunately not. It's not a running service. They just converted. Sometime in 2021, they converted all previous papers to HTML5, but new papers are unfortunately not converted.
They run it once a month. So they're behind by 1 month, but they're also heavily working on speeding up the whole process. The problem with LaTeX-ML currently is that it's a bit slow, in particular if it depends on XPL3, because then it has to like parse the whole 20,000 lines of XPL3 code.tech or whatever. But they're working on that as well, and they're heavily planning on integrating it as a live service as well, so that you immediately get HTML preview once you submit your sources.
Well, I want to make sure that I understand the last parenthesis on this slide correctly. You have implemented in your Rust Tech a complete implementation of the Tech macro language, an expansion.
Yes.
Okay.
That I have done. Unfortunately, as I mentioned here, I learned both Rust and Tech while I did that. Yeah. So as a result, to me, this just looks like horrible spaghetti code that should definitely be cleaned up. And that's what I'm trying to do now, like properly modularize it. In particular, I can't handle any kind of ZTech, because ZTech has entirely different character types than like plain tech does. So yeah.
My advice is go away from math, call stomach and state, and talk about lexical analysis and abstract syntax types and work on them.
Yeah, I'm doing everything with generics now. Yeah. So that you can just conveniently switch out the mouth by a different mouth, or the stomach by a different stomach, or primitive commands by different primitive commands, and even like the character type, whether you operate on bytes or on actual Unicode characters.
One question, how do you handle marks and inserts? That stuff that goes on top of the page and footnotes and floats. And
currently, I do that by regularly checking if I'm at the top of the document level, and then checking whether any of the float registers or any of the inserts are handled. So in lieu of a ship-out routine, I'm kind of faking that to generate footnotes and floats. But they will just be inserted at the next convenient place, not using any kind of ship-out routine with computing pages and so on and so forth. So that's kind of a workaround currently. But they're there.
Thank you. And when you're ready to talk, there's a power switch there.
Okay, thank you very much. Okay, you introduce me first.
Just Patrick Gundlach will talk about boxes and glue.
So thank you very much. This is a follow-up from my last year's presentation on boxes and glue. And when I submitted the paper, I thought about talking on news on boxes and glue, but that would have been a very short presentation. So, how does it work? This. Okay, I changed the title internally to Lessons Learned. And maybe it's a mixture of both. So before I go into the details, I would like to have a short recap on what is boxes and glue. So boxes and glue is a collection of software libraries. It's not a ready-to-run piece of software, so it's not an application. It's written in Go. It's the attempt to bring taste-superb output quality to a modern environment, and it's, of course, open source. So why do I create, or why have I created boxes and glue? My day-to-day work is to create product catalogs and other similar documents. I use software built on top of LuaTech, and it works really well. And LuaTech is a totally awesome piece of software, and it's very good. But LuaTech has limitations. For example, some trivial limitations, like it cannot do any HTTPS requests. I don't know if it's still true, but at the time I looked at it, and I need this every day. So I had to write a wrapper around it, and there are also other limitations which made me to think about writing a replacement for LuaTech. So since I've used LuaTech a lot, the implementation of boxes and glue uses the same data structures and the API of LuaTech, especially the nodes, like the small pieces you have on the paper, on the page, the glyphs, rules, and so on. The node packing algorithms like hbox2, whatever size, and bbox2. Everything is a rectangular item, maybe stacked together. The line breaking algorithm and the hyphenation algorithm and a few other things. So these are very similar in LuaTech and boxes and glue. Hello? Okay. Last year, I've also presented the architecture of boxes and glue. So it is split into two parts, a backend with all the necessary parts to create PDFs. For example, the nodes are in here, and the line breaking algorithm, and some other necessary stuff. And there's a nice-to-have front end, which is not strictly necessary. You can have like CSS, HTML typesetting in there, and collection of font families and so on. So it's built on top of the back end. And of course, you need some kind of application that uses these libraries. And last year, I've also presented some kind of progress bar, how far I got with the implementation. And it was like this. And now comes the news from boxes and glue. You have to watch carefully. This year, it's it's a bit more. So I think the backend is more or less complete. So you can write PDFs, and there's pretty good support for it. And this last year, most of the work has been done in the CSS, HTML backend. And there's also some progress in the applications. Currently, I'm working on two. The main application I use is the catalog software, which is a direct replacement of my software I've I use currently, and some HTML, CSS type setting. We just put in some web page with CSS, and you get a nicely printed PDF document. So talking about history, some time ago I ported the hyphenation algorithm to LuaTeX, and somebody commented, "Are you going to port LuaTeX to Go?" I said, "Oh, it's a long-term project," and so on. That was 7 years ago. So I think that was pretty much the start of Boxes and Glue. Maybe I'll give a short timeline. I experimented in the beginning with taking the web source code from Knuth. I started with DVI type, which is a very small program, and I tried to rewrite this in Go one by one, like taking exactly the same data structures and codes and so on, just change the syntax so it compiles with Go. And after finishing that, it works, but I said, no, I'm not going to do this because it's not extensible. It's still the same code, but it's hard to extend. So I thought a long time about how to do this, and then I started rewriting the algorithms from TUG into Go. There started with the hyphenation algorithm, did some other things, then I did some typesetting experiments, and 2 years ago I started the first commit, or the first code on Boxes and Glue. I tried a Lua front end, but I threw it away because it was too early at that time to have an API. Since I use XML a lot, I also had to write an XPath library and some XML stuff. And the XTS stands for Experimental Typesetting System, or XML Typesetting System, is the one I use currently as a test bed to continue the development. So currently I work on CSS, HTML typesetting, and hopefully next year I will have the first productive use. So there's, I can see the end of the first version, or the beginning of the first version. So my next steps or wishes are right to left and left to right typesetting like Arabic. And I also need some kind of graphics library. Metapose is very nice, but it doesn't exist in pure Go, so I need to find some replacement for that. Also, I would like to have a paragraph shape to have text wrapped around images, for example. So this is also from last year, my design goals of Boxes and Glue. So I would like to have text output quality, performance. I would like to see the text data structures, and left to right or right to left, or mixed bidirectional typesetting, and to support PDF standards, a variety of PDF standards. And I also have a progress bar here. So there are some parts better than the others. And the second item, the performance, is quite important for me. LuaTeX is very fast, contrary to what people say. With plain TeX macros, I get 500 pages per second with LuaTeX. And I did some benchmarks yesterday with my catalog software, which has some kind of macros or stuff, layers on top of LuaTeX. I get about almost 50 pages per second, which is also quite fast. With Boxes and Glue, I'm currently at 300 pages per second with the same document. So I think this is quite okay. So lessons learned so far. It works, yes. It's not a really lesson. Writing PDF can be difficult, and again. So it works. The middle one is some CSS, HTML typesetting. And the right one was an example from my old catalog software, which I have now ported to the Boxes and Glue. So there is output possible, and I'm really happy with it. next lesson learned is like PDF can be difficult, writing PDF can be difficult. PDF looks like an innocent file format. It's just plain text and a bit of binary data, so it's actually not that hard to write. But the spec has around 1,000 pages, and there's not only one spec, but you have to read different kinds of specs. So you can see from that number that it's not that trivial. But it is innocent or easy at the beginning. For example, to include a PNG or bitmap image, you can just write an object, which is a dictionary, type X object, subtype image, and then some parameters, and then the compressed data. You put this in the PDF file, and you actually get an output. And I said, ooh, that's easy. Then I came up with the next image. I tried to include this. It came out like that. You see the strange four corners? I said, okay, no, what happened here? And I finally found out that these four corners are transparency. So I had to look up the spec again, find out how transparency is implemented with bitmap images. I implemented this and I said, great, finally got it. So I tried to include this image. This is a gradient also with transparency. It came out like this. Ah, no, bummer. So I had to reread the spec, debugged a lot, and finally found out, okay, if this is some kind of soft mask, we have to write a different kind of object and include this as a transparency object. I finally got it, and it came out like this. And I said, no, okay, I read the spec. Got it, finally. So then I prepared a presentation for TUG. I tried to include this image, and it came out like this. You see the small white line. I said, okay, maybe that's a display error in my PDF, or the display is broken, but no, it didn't go away. So I had to reread the spec and fix some errors. So it's trivial to start, but the devil is really in the details, and it's also with fonts and other things. So it's easy to write, but you have to consider a lot of things. So writing PDF is hard, I think. And again, but not less and less and less. So I'm still as clever as before. So I always encounter errors. So there are different kinds of errors I encounter. For example, I put this table and one cell just was shifted a bit too high. Or this funny T, I call this, I don't know, somehow the T appears incorrectly. I fixed that bug finally, but I was not happy with it at the beginning. But most of the time, when I create an error, it looks like this. I get an empty PDF, and I said, okay, thank you. And then I open the PDF in Acrobat, and Acrobat tells me, an error has occurred, or please contact the person who has created the PDF. Glad I have his phone number. So, actually, gladly there's, in Acrobat there's a way to check for errors. Okay, there's a pre-flight menu in Adobe Acrobat. We can select the item, check for errors. And then it will analyze the PDF, and you might get an output like this. It might be hard to read, but it says, okay, on page 2, you have an error on this object, and this key is missing. So you really get to understand, okay, this is what I've done wrong. Then you can fix it. And when you're lucky, you get like this. Or if you're totally unlucky, you also get this. Because sometimes I open the PDF, it says, no, it's totally broken. Call the author, the creator of the document, and then I do the error checking and it says, okay, no errors found. So it's hard to debug errors in the PDF. Tools for PDF debugging. As I said before, I use mostly Adobe Acrobat to check for errors. But sometimes I open the PDF in the text editor or read it with less because it's a plain text file. And you can just ignore the binary data. You might have to decompress it first if you're looking for foreign PDFs which are compressed. But you can do this with QPDF. And opening it in text editor is very good to read. There's also Vera PDF. It's an open source checker. And for accessibility, there's a PDF accessibility checker. And I've just learned that Ulrike has also some more links for PDF checking. And I will extend the slides perhaps later. So the slides are also on the homepage of the TUG. So when I develop new features in PDF, I usually save the PDF, open Adobe Acrobat, check if it's okay, and then create a new feature. So it's a very tedious workflow because it takes a lot of time, and I cannot automate this. And I wish I could automate this. Debugging, speaking of debugging, I've shown this before where the PDF is okay, there's no syntax error in the PDF, but some logical error in my code somewhere. And there's how to debug this kind of problem. There are several debugging techniques to get to this kind of error. You can use a step-by-step debugger, like clicking on next, 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 to see where the program goes. I don't like this because it's too much time. You can do some kind of visual debugging. This is actually not from Boxes Included, this is from LaTeX. This helps checking alignment things also. It's nice. My most favorite debugging technique is actually the printf debugging. We just write in some code, the input is A or something like that. So very simple, but it's actually the one I use most. Rubber duck debugging, I put this in mainly for Polo. This is where you look at your rubber duck on the desk, explain the source code to the rubber duck, and then during explanation you find out, oh no, this is the incorrect place. And gladly, the rubber ducks cannot speak because they might embarrass you. So, printf debugging. It works only for simple cases. When doing typesetting, you sometimes have a lot of information on the page, nested data structures, boxes, inside boxes, lots of glyphs and other things, and there printf is getting hard to read. So it's too much output for data structures in typesetting. And now how do I understand the generated node list or the nested node list? I need some kind of structured output. I used to have this representation with my software based on LuaTeX. I create a dot file from the internal data structure, which you can use with GraphWiz and create some PNG or PDF output like this. But this gets really ugly because these lists can be so huge, and then you have to scroll through the document and find the right place which one you want to check. And then somebody came up with another representation, Josef Friedrich. This is actually the one I like most because it's structured, but it's also a bit verbose, but it's very nice. You can use this with LuaTeX. And with Boxes and Glue, I switched to even more verbose output. It's based on XML. You see the node lists or the boxes nested inside boxes as HTML, XML representation. But this is really handy because you can load this into your text editor and use code folding, so to hide the inner boxes you don't need. And you can use some query language to find the positions where you want to look. So this is also from last year, my great wishes, what to implement next, like experiment with the algorithms, doing optimization for page breaks and paragraph breaks, or to do parallel tasks to speed up things. And I have to admit I've done none of these items yet, so this will be on next year's presentation for my next steps. Okay, 2 conclusion slides. Porting TUG algorithms and data structures is possible. Development takes much more time than estimated. I know that's trivial, and I want to extend this a bit. Since I don't have a deadline for it, I can play with the code and throw away code when it's not good or if I go to the wrong direction. And this is a very great luxury I have because I don't have any boss sitting behind me and saying, okay, next week I need this thing done. Okay, and seeing the results keep my motivation high. Without that, I would not continue working. So the last conclusion, I would like to conclude with this poem. Roses are red, violets are blue. I create my PDF with boxes and glue. Thank you very much.
Thank you. Any questions? Not even Boris.
Everybody wants to go to lunch, I guess.
You ported the TUG algorithms. One of them is show node list. Did you port that too? That was Don's way of showing node lists when he was debugging.
Actually, I have never looked into this, so the answer is no.
It looks pretty much like the last slide you
had.
had.
There was some parentheses around this with dots.
You should just set max depth and max breadth and then the full thing.
Okay. Actually, I have never seen that.
Look at it.
So why Go?
What?
Why the Go language as opposed to Rust is popular this week?
You have to choose one,
Lua.
and it was just a language I know best, and there are several reasons, of course, for it. It's not just a random choice. With current implementation of LuaTech, I create binaries for Windows, Linux, and Mac. But it's hard because I have some wrapper libraries around this, and I have to cross-compile it, and it's a bit tricky. And with Go, I can just cross-compile everything from one single step, for example. And this is actually a key feature for me. Other languages have that as well, but I have to choose a language.
You talked about how important performance is, and you said that you're getting around 5 times the speed of LuaTech for simple. What's driving that improvement in performance? I would normally think of the LuaTech code as already quite well optimized. So,
actually, I have no idea. No, seriously, I have this. I use the Lua API of LuaTech, and I have just a few wrappers around this, not too many. But this somehow it's my code is not optimized, or this API is slow. I don't know. It's still very fast, and people come to me and say, "Oh, this is so fast, and InDesign is so slow compared to that." So I didn't think about it, but now I use also bare metal code. It's much faster, but I have not looked into it before.
Well, thank you. Next step is going to be lunch.
Direkt in den Hof. Ich glaube nicht, dass die zugemacht wird.
No, now it's, you say lunch, and they should come in time for the photo.
One last thing, we're going to come back a little before the scheduled start time to try and take the photograph of the group. Time? Have you said time? Everybody. All right. So this, it starts, the afternoon session starts at 2 o'clock. If you are here at 1:45, we'll have plenty of time to take photograph.
Just say something about lunch. Yeah, about lunch, you can either choose a place on the terrace or on the inside, which is probably nicer. Outside is pretty nasty. And there's a buffet built up where you saw it yesterday. And I think water is for free and the rest is on you. For drinks, I mean.
And I have one very quick announcement. As you may have noticed, there is ducks. I would just like to ask you, we are not sure how many we are, and we are not sure how many ducks we got. So for today, please don't take more than one. And if there is any left over tomorrow, then you can take more, I think. Just to give everyone a chance to get one, because we are not sure how many there are. Thank you.
Hi. There's one more announcement organization-wise. Yesterday there was in the evening some light dinner. Some people may have misunderstood that this dinner was to be paid by themselves, either on the hotel bill or directly. So currently TUG is roughly short about 6 meals, and it would be nice if the people who didn't pay yesterday evening go to Robin and check out with her. Thanks.
Okay, thank you all for being here. For this session, we got plenty of very good abstracts. And now we are welcoming Sam Carter and Joseph Wright. So Sam Carter is a physicist here in Germany, and Joseph is a chemist in North Anglia. They did plenty of contribution to projects around LaTeX, but they are here to speak about Beamer. There will be 2 parts in the talk. I think. Do you want all the questions at the end of the talk?
Yeah. First, the questions about Beamer, and then for the second talk separately.
Okay. So there will be a question session in the middle.
Thank you. Okay. Welcome to the Beamer News. In this talk, I would like to bring you up to speed. I think it's a bit too close. Up to speed with the recent developments in the LaTeX Beamer class. Just as a quick recap, Beamer is a LaTeX class which is most often used for producing slides for presentations in LaTeX. For example, the slides behind me are produced with the Beamer class. It was originally written by Till Tan Tao in the early 2000s with a lot of, for this time, revolutionary ideas. Since then, it even gained more features and now has a very large user base. Some of the users using it for many years, some even for over 10 or over 15 years. At its current point of its life cycle, we maintainers mainly focus on stability. We fix bugs, we keep things from crumbling in case some dependencies like the LaTeX kernel or other packages change. But really big changes are usually out of the question to ensure backward compatibility so that the users can still compile the slides from 10 years ago. Nevertheless, we were able to make a few smaller changes, which mainly focus on improving the usability of Beamer. And some of these changes we would like to show you in this talk. The first change is that Beamer now has transparent shadows. Previously, the shadows were calculated to go from black to the background color of the slide. The background color usually being white. This led to some rather strange-looking white halos on slides with background images, which often occurred on title slides. In Beamer version 3.51, Andrei Paranomov contributed some code which would make these shadows transparent. Unfortunately, this code didn't work well with some of the engines, like LaTeX, and had to be reverted. So that was only the beginning of a very long story. Several versions later, Ulrike Fischer found a bug fix which allowed us to use transparent shadows even in LaTeX and some other engines. And then it took another 10 versions of Beamer to change all the places where shadows occur, in headlines, around blogs, And hopefully now all the shadows are nice and transparent. Another change is that aspect ratios are now more flexible. Previously, Beamer had a fixed set of commonly used aspect ratios, but users kept asking for different aspect ratios. Apparently, many countries use different aspect ratios and would like to have them also in Beamer. And now Beamer keeps the aspect ratios which were already there. They are untouched, but users can now also input numbers with 2 to 4 digits, and Beamer will automatically calculate the aspect ratios on the fly. For numbers with 2 or 4 digits, the number is split in the middle, and for numbers with 3 digits, we assume a landscape format of the slides. This way, you can now create different aspect ratios. You can create very tall slides, you can create very narrow slides. Internally, use a fixed height for the frames, so they are all 9.6 centimeter, and calculate the width accordingly. Many Beamer presentations have lines which are not totally filled. Like on this frame, you can see that the lines only span maybe half of the width, and having a fixed height and just changing the width allows that the layout of the slides mainly stays the same. So if I would change this slide, make it smaller, the layout would still work, and users can switch between aspect ratios without too much problems. Yeah.
Is there a difference between 69 and 1609?
No. For 4 digits, it should still be able to calculate that. I didn't look up what 60 to 9 was an originally existing ratio, so the actually slide dimensions may be different than the calculated ones. But just in terms of absolute units and not the aspect ratio itself. Okay, there's also a new class option, the only text width option. Just a quick reminder, Beamer usually changes the margins of column environments. Locally, the user can change these margins back to normal text margins with the only text width option. And now that there's also a class option, one can do that at one point for the whole presentation. And we also have a new frame option, the S option, in addition to the existing C, T, and B options. This option is for stretchable materials. It was contributed by Eric Schubert. And if you want to distribute your content across the whole slide from top to bottom, you can use it. The one important thing to remember for this option is that you need something stretchable on the page, like a vertical fill. And in the most recent Beamer versions, the title page is now more modular. Previously, the whole title page was one big monolithic code block. And if a user wanted to change something, maybe change the order of the fields or add some information, they usually had either to hack the fields and smuggle the content in somewhere or to redefine the whole title page. Now the title page template uses smaller sub-templates like the title, the author, the institute, the date, or the title graphic templates. So you can either redefine them or easily add stuff to them. For example, on this slide, there's an example where a name of a supervisor was added to the author template, which can be useful for something like thesis defenses. There's also a new note page template, which is heavily inspired by the handout with notes package originally written by Guido Diepen and now maintained by Marij Peischel. This note template can be used if you want to give your students the option to make handwritten notes for the slides. Similar to the changes with the title page, the foot line was defined as one big block, and if users wanted to make small changes, like change the format of the page numbers, they had to redefine the whole thing. Now they can simply redefine the page number in head foot template, which changes if page numbers or frame numbers or the total frame numbers should be shown. And the table of contents command also has a new option. We already had the first section option in place, which allowed the user to have unnumbered sections at the start of the presentation. And now we also have the last section option, which allows the users to have unnumbered slides at the end. Maybe the user wants an appendix or a summary slide section which is not numbered. This option can be used in such cases. There are a couple of new user-facing macros. For all presentations, there is now the inspect aspect ratio macro available. This will give the user the number they previously input for the aspect ratio. So for example, the default value is 4:3. And this can be used if you have a template or a theme which should be able to be usable with different aspect ratios. If you have a title page with a picture and want to use a different picture and another aspect ratios, this option is useful. And for the sidebar theme, there are now the sidebar width and the beamer head height defined, which could, for example, be used if you want to scale a logo to match the dimensions of the sidebar. And then one last, but maybe a bit influential change. We changed the point when the frame geometry is calculated. Previously, Beamer only calculated the frame geometry at the start of the presentation, which caused problems if you wanted to use different head or foot lines throughout the presentation. Now, it is calculated at the start of every frame, which means that you can have frames with headlines of different height. For example, a very big headline on section pages to make them stand out. Or you could define the foot line based on frame number, so you automatically don't have a foot line on the title page. That's now all much more easier to do. And that was a couple of highlights we picked out to show you. If you want to know about all changes in Beamer, you could follow our changelog on GitHub, or you can read our announcement posts on C10. And with that, I would like to thank you for your attention.
Which version do I need to use these features?
They are always at the top right, written the number. For example, here is 3.70. This is the current version if you use an up-to-date text distribution.
Some other questions? I have one. Why did you, for the definition of the aspect ratio, why did you drop the separator? Previously it was using a column?
That was to stay with how they were always defined. So they were already defined without separator, and we just keep...
Maybe you could have defined a new one, huh?
It would have been possible, but this was just to stay in this scheme. There's another question.
You picked the choice to always handle 3 digits as landscape orientation. Would a leading 0 be recognized as the 4-digit notation or a 3-digit notation? Because with the leading 0, I could, in theory, input a 3-digit vertical.
That's a very, very good question, and I didn't test that. I would have to look into code.
Yeah, I think it would. think we just need double tokens.
I think I used some modular operation to get the numbers. I would have to look at it inside. We will answer that offline.
Are there other questions? If not, we could switch to the second part of the talk. So that's about T-color box.
Yeah. The next talk?
It's a video?
Yes, the next talk is.
So we will need the video.
No, the talk. The slides for the next talk. Okay, with the next talk we stay in the Beamer ecosystem, and I would like to show you the Beamer T-color box inner theme. You may ask, there are so many themes, why do we need a new theme? Over the last few years of answering questions about Beamer and looking at the Beamer bug tracker, there came questions like, I like the box with sharp corners, but please with the shadow from the rounded blocks. Or why is there an empty blue box at the top? Or can I add a line around the block? Or the shadow vanishes if I include my presentation in another document with PDF pages, view it with a bubble-based viewer while a black cat walks by my window during full moon. Okay, the last one was a bit exaggerated, but what do they say all these questions have in common? They would like to change the Beamer blocks just a little bit, but due to the way the Beamer blocks are implemented, even such tiny changes usually require rewriting most of the code. Now comes the T-color box inner theme to the rescue. The T-color box inner theme replaces the normal Beamer blocks with T-color boxen from the package of the same name by Thomas Sturm. Everyone who's ever used the T-color box package knows how incredibly powerful this package is. And with this theme, we bring all this power to Beamer. To make the transition between normal Beamer blocks and the new theme easy, the theme detects what other themes you've already loaded in your presentation and adapts the look and feel of the blocks to match what you would have with normal Beamer blocks. In addition to this automatic adjustments, the user also has a number of options which they can use to change the appearance of the blocks. The rounded option says if the corners of the blocks should be sharp or rounded. The shadow option dictates whether there's a shadow behind the block or not. And the click thing doesn't like me. Yeah, no. And the shaded option is probably a bit hard to see on this presentation. But what's normally happening is that rounded Beamer blocks have a slight color gradient between the title block and the body of the block. And this option switches this gradient on and off. In Beamer themes with sharp corners, there's a small blue bar shown if the title of a block is empty. The show title option allows the users to replicate this behavior with the T-color box inner theme. The in-margin theme is for themes like Bergen, where the block title is printed in the sidebar. And the last two options, the block and the title page option, are switches which allows the user to switch on or off if the theme should replace the blocks on the title page and section pages, etc., or the blocks in the normal presentations. These options are useful if you want to replace just the one and not the other. And I've already mentioned that the TUG Colorbox package is so powerful and that we now have all this power available, which means that we can easily alter the appearance of Beamer blocks. Here an example where you can use the TV set for every layer macro to quickly change to a centered, smaller block title with just these couple of lines of code. The exact interface may change because Marai noticed that there's some incompatibility with other TUG color boxes, but the ability to change will stay. On the next couple of slides, I would like to show you some examples to get some inspiration what can be done with this theme. On this slide, we added a border around the blocks if they should be a bit more contained. On the next example, we moved the block title to the corner and changed a bit of the layout. Here an example where the title of the block is a color gradient. And here an example with a background image. The ability to use a background image can be used for some fancier stuff. For example, on this slide, we use this technique to fake a blurred, semi-transparent background for the blocks. This is inspired by some operating system. I think Ubuntu uses a similar layout for their terminal where you can see the background image blurred a bit, but still the text is readable. Okay, after these couple of examples, I'm already at the end of this quick talk to show you the TUG Colorbox inner theme. I would like to encourage you to try this theme out, and if you face any problems or have any ideas how this theme can be improved, there's a bug tracker available at GitHub. Please feel free to upload any problems or suggestions there. And with that, I would like to again thank you for your attention.
Thank you, Sam Carter. Are there questions? I have a small question. Are all those new features that are really sexy available when you're not in a Beamer document?
Sorry, I didn't understand this.
Are all those features available when you're not in a Beamer document? Are they linked with Beamer?
They might. The package might work with a Beamer article. If the Beamer article package is loaded, then it might work in a normal document class. But honestly, I didn't yet try that. I just wanted to replicate the blocks for Beamer slides.
Okay, I will try.
Thank you. Please let me know how that works.
Some questions? We have plenty of time. Okay, if everything is clear, let's thank again Sam Carter and Joseph Wright. And move on to the next speaker.
How do I put this logo? Okay.
That in your pocket or your belt.
See whether it will work. Okay, and how do I move slides? Okay. Okay.
I will introduce you briefly.
Yes.
So we are now welcoming Boris Weizmann. He's both a biologist and a physicist, a really creative scientist, but he's here for other skills as a graphic designer because he developed a class for a publishing company, and we'll tell more about that.
Yeah, thank you. So I would like to tell about some work I recently did for No Starch Press Publishing Company. How I move the slides? How? Which this one? Or maybe this one? Ah, now I got it. No, this laser. Oh, I got it. Okay, No Starch Publishing Company was established in San Francisco by Bill Pollock, a person with really great charisma and a lot of opinion. To understand what is this, I would suggest you to look at the About page on the website of the company, and it's basically a proud list of publishers which fired Bill Pollock previously. And he seems to be very proud of the fact that some really big companies would not work with him. He opened his own company which has the idea that this is the finest in geek entertainment, whatever this means. If you look at the publications of this company, you will see a lot of interesting things. There are something which you would see in a normal publishing company which publishes technical and computer literature, like a very good book about R or book about GIMP or TCP/IP guide. But you also would find something like biochemistry in manga style. You can find a lot of books about Lego, and basically the topics of the books and the way the books are done reflect what the company thinks is good for geeks or nerds, both as a work and entertainment. And it's very interesting, very nice, and I think it's some vestige of the old geek culture before a lot of geeks started to think about grabbing more money and getting millionaires and billionaires and so on. And this is what you would think about classical people who were maybe nerdy, but somehow very interesting. You might understand that people with this mindset have very strong opinion about the way books should be done, about typesetting, about artistic qualities, about design, and yes, this is the case. So my work was to help them to implement this design and their design features in LaTeX. I started working with them many years ago, at 2008, even before I came to California. It was in East Coast, and I tried to implement what they did in InDesign and other things. I was much younger, so I didn't implement a lot of things which is embarrassing because they should be implemented. And besides, they changed some things, and they never consulted me about the changes. And so at some point, they just added patches to the class file, they added patches to the other things. So at some point, it became even worse that my ICM art class, which I patched for 17 years, they patched for some smaller amount. So there was a need for some changes to make it better. One of the reasons why they needed this change was because of nice people from Overleaf here. Because one of the things about Overleaf was that a lot of people started to use it for making LaTeX files. A lot of people who would do word processors would say, okay, we have now version control, collaboration instrument, and so on for free or for reasonable pay. let's do it. And they found that they found that no starch presses, they have a lot of submissions in LaTeX, and at some point they decided to hire me to update their class with the current situation. So I just wanted to say that, as usual, I'm very grateful for people from Overleaf. You really help a lot of us, and me including, to get some modest money for our efforts. I wanted to automate what they were doing. I wanted to automate it as much as possible, but I still did not want to, you know, you have 95% of effort in the last 5% of functionality, and I decided, okay, let's not do the last 5% functionality, let's put a lot of override features. Everything should work from the box, but if it does not, then they would be able to change it. So today we'll tell about a couple of tech-related challenges and solutions. The first thing is about URL splitting. There is a huge controversy whether you can split URLs on hyphen. And the reason is very simple. If you have URL split on hyphen, the question is it hyphen a sign of hyphenation, or is it part of URL? And obviously, we all know that no, URL's a special case. If you have hyphen in split URL, it's part of URL. But there are still some readers who don't know about this convention, and you are going to confuse them, even if, especially if they work with a hard copy, so they cannot just click on this. And people at No Starch Press have a very simple and I would say elegant solution of this problem. They say, yes, you can split on hyphenation, but only before the hyphenation. So, and if you see the hyphenation sign on the next line, you perfectly know that, okay, this is part of the URL. Actually, they have a lot. Actually, they have a lot of rules. They have some characters you must split. You can split after. There are some characters you can split before. There are some rules that you cannot split before slash. In particular, you cannot split colon slash slash. HTTPS colon slash slash should stay the same, and so on. By the way, they split, just an aside, they split before question mark and exclamation mark, and you might think that this is wrong, but it's not, because unfortunately, due to the strange syntax of URL, question mark, ampersand, and exclamation part in the URL scheme is the beginning of the group, but not the end of the group. So you should split before them. But this is okay. So I said, okay, let's use urls.sty, and let's look how it does URL splitting. And if you don't know, it's a funny thing that URLs from the point of view of URLs sty are math expressions. They basically map everything to map. And then how do you do splitting? Well, there are rules for splitting of mathematical formula. You just say that some sign is a binary relation or binary op. You can split after binary relation, binary op, and that's fine, everything works. Now, how do you split before something? Because in traditional math typesetting, by the way, this is Western typesetting. In Cyrillic typesetting, you split before some signs, but not in Western. How do you implement it automatically? And it turns out that it's easy to implement, because another feature of url.sty, they have this do specials command, and you basically can tell anything which should be done with your sign. So here is an example how I can split before dot. I just say the dot is not ordinary symbol, it's not bin or mat.rel, it's something special. And what is special? It means that before dot I just add a penalty which corresponds to bin penalty, and then matchar 46 is actually dot. So the basically thing is that if you see in URL dot, you put a penalty, so you can split before it, and the dot itself. And the same goes with the rule that you cannot split, for example, before a dash. You delete all penalty before, you put very high penalty for splitting, and then you put dash. Everything works fine. Unfortunately, I have a problem which I cannot. Okay, I probably can solve, but I don't know why. It does not work. AMS-MAF redefines some cat codes for opening delimiters. It needs it for its own magic with delimiters. And somehow it clashes with the way I do it. So I found out that you have AMS-MAF and my changes, you have an error. So because some authors of no starch use AMS-MAF, I no longer split before opening bracket. I really don't understand what happens. I did not spend a couple of days, I spent a couple of hours trying to understand what's going on. But as everybody knows, category codes and the magic of category codes is sometimes a black magic. So I still don't know what happens, why I have this strange error which when I try to redo this thing. Okay, next problem. Next problem is actually not about update, it's something I solved in 2008, and this is about chapter start. And chapter start in no starch press books is different from anything I have seen in mathematical books. It's very close to something you have seen in classical books. It's a first paragraph which starts with a font a little bit larger than the font of the body. It has this strange circular art. You put some circular thing here. Here I just put euro, not because they always do it. I wanted something round, for example. And because you put some circular art, you need to have a special shape of the paragraph. Fortunately, this is the situation when where a classical LaTeX has hooks even before, it works even before the new hook mechanism is there, and you have nice hook in section which is called after heading. So what you do, you add to after heading. It's basically the same thing you do when you try to make the first paragraph not having indentation in the normal classes. You do some instructions to after heading about how to do it. And then you say that after you do it, in every par, you redefine every par, so you throw away my redefinitions. This is brittle. I hope that we probably have a better mechanism. Brittle is because if somebody else wants to redefine every par, they would be out of luck, or I will be out of luck, but at least for the controlled situation, it works. The last thing I wanted to tell you is something which I did not do many years ago, and people did this manually and very much pissed off, so it was incentive for me to do it, and now I did. If you look at the tables and figures in the no-starch books, you will see that they are interesting. First, they are not centered. They are flushed left. Second, the caption size is a variable. They want the caption to be exactly the same size as the table or figure. So if you have white, still less than the text width, but white figure, they want caption to be white. If it's narrow, they want it to be narrow. Of course, you need to understand that if it's very narrow, then you probably want to redefine it. So I wanted to do it, and the way to do it is this. The caption package, which in the workshop was criticized by Ulrika, but I still is one of my favorite packages, has a very nice way to typeset caption in the way you want. And one of the things you can do, you can say that you want to typeset caption in a box of the given width. Fine. So what you need to do, you just say that this width is variable, and before you start typesetting caption, you just measure the proper width. Fine. So how it works? With figures, it's very simple. It's a lot of TUG code, that's usually with boxes and last box and so on, but the idea is very simple. You have a figure, and probably it's some sort of a box. You take this box, measure its width, and this is the width you want to typeset caption. And you typeset caption exactly to this width. So what this chunk of code does is just this. Take the box, and before the strange way TUG works, you need to take it and then return it back because it's not non-destroyable, because when you take it, you actually change something. And then you put it back and calculate the width, and that's fine. What you do with captions? You cannot do this with captions. And the reasons you cannot do this with, what you do with tables? You can do this with tables. And the reasons you cannot do this with tables is because tables in no-starch books, unlike the tables in Lampard and many LaTeX things, are typeset before the table. So when you typeset the caption, you don't know what the width of the table is because you did not typeset the caption yet. Well, we all know how to do it. You use the magic of auxiliary file. You measure at the end of the table, you measure its width, you put this width into auxiliary file, and when you typeset caption, you look at the file, auxiliary file, and if you know the width of the table, you typeset it there. So here is a code. This is a writing. It's a lot and a lot of code, but basically there are two things. First, you take the last box, measure its width, and second, you need to check whether you already have this width. And if you have this width, whether it's exactly same as in the previous run. If it's the same, fine. If not, it means that you need to tell LaTeX to rerun it and do it again. So you need to check and generate. And you need to create a unique macro. And the idea I actually stole from, of course, long table package. You need to have a unique macro, which is unique for this table, which keeps its width, and that's how you do it. This reading. Again, the same thing. You calculate the name of the macro where a width is. You look whether this macro is defined when we have read auxiliary file. If it's defined, great. If not, we put some default value like the width of the page. Long tables. Because no-starch uses long tables, I need to do the same with long tables, but with long tables I have a better situation because long tables know their width. They actually put it in the auxiliary file. By different reasons, they want to know the width of each column to be able to make column the same, but because they put it there, I can read it, I can check it, and I can put it there. Again, it's brittle because the day that long table code is changed, I'm out of luck, but so far so good it works. Yeah, I understand. Well, that's the way we used to do LaTeX in the old days. We always were relying on the kindness of the stranger offers of other packages. Okay, we need override because it's all good and fine, but what happens if you have very narrow figure? You will try to typeset caption to a very narrow thing. You can actually override it, and that's the way how you do it. You just put a command like next caption with something, and when this caption is there, you override caption for the next float. So basically, I want to say that there were some interesting challenges, And it's interesting that it's possible to do it, and it's possible to do whatever they did manually in InDesign or whatever they did with other things and do it automatically and faster. And the next thing what we want to do, they still want to do besides PDF, they want to do e-books in the EPUB format. I completely agree with many of you that it's not a good idea, but they want to do it, so the next thing is to try to make EPUB work for them. Okay?
Thank you, Boris. Are there questions?
So in the part about URL splitting, you mentioned that you break after hashtag or after...
I think it's after hashtag. I need to look, but I think it's after hashtag.
But you mentioned that for question mark, for instance, you break before because it introduces a group in the
Yes.
URL. The same is about the hashtag because it's actually the section mark in the URL. So why after there and before question mark?
I probably would agree with you, but as I said, I worked with the house rules which were written by Bill Pollock, and I didn't want to. So I basically, he said, do it after hash mark. Okay, let's do it after hash mark.
Do you maybe have an estimate for how much this whole project took? How much time?
Yes. You mean update? Okay, I would think that update was something like 3 or 4 hours of 3 or 4 of billable hours, and the initial design was many years ago, but I probably also something like 4 hours. So altogether, it's something like 8 hours of work. Approximately. I might be wrong, but that's what on the top of my mind.
Let's see. You asked what you can do about this every par thing.
Yes.
Perhaps better. I haven't checked, but I would say add to next hook,
yes.
And then use the power hook that is available.
Yes, and this will be in only one paragraph, first one. Yes.
Yeah, that's for the first paragraph.
Yeah.
Then.
Again, this code was written in 2008. So,
okay.
Yeah.
The second thing, Ulrike just you said Ulrike doesn't like the caption package, and we
yes.
said so. In the
caption 2.
You
maybe.
I think you misunderstood something there. Caption packages is just fine.
Okay.
Nothing said yesterday, I think. And the third one, you showed this global set length or global set add to length. That actually doesn't work.
Which global set?
Oh, well, two, 3 slides back. I don't know.
How do I back? Oh yeah.
Stop. One more, isn't it? Next one. No, in order of. Forward, not backward.
This one or next one?
Forward. There's global set length on the top.
Yes.
And it doesn't do anything global.
You are right. It just. Yeah, again, it's
not supported syntax, and if the calc package is loaded, which many packages do, you suddenly don't get any global change. So just as a warning.
Yeah, okay, thank you. I probably need to delete global here. Yeah, thank you.
So 2 short remarks. The problem with the line break in URLs, I think it's not that hard because if you use a monospace font for a URL, I do it just to distinguish probably between a lowercase l and an uppercase I. then the dash is considerably longer than an ordinary hyphen in a text. So a careful reader could distinguish between these two.
Yeah.
And the other thing is more about the contents. The problem with long captions, I think, is basic in many cases is authors try to describe the contents of the picture in the caption, but that it's hopeless. You should describe the contents in the text and not in the captions. The only thing that the caption should do is to distinguish the pictures in the list of figures, for instance.
Yeah. I completely agree, but two things. First, unfortunately, okay, I used monospace font in my example just to show example. In No Starch, they use italic, non-monospace, but body text italic for their URLs. Again, it's their solution. So, and second, I wouldn't say their captions are long. Usually they are quite short, but if your figure or table is narrow, then you cannot do it in one line anyway. Yeah.
Any other question?
Okay.
About the workflow between you and the publishing company, how did you communicate? Because they had quite unusual requirement, and you could have tried to explain to them that.
Okay, good question. I always try to do my communications in writing. First, because it's much more efficient, and second, because at least I have a paper trail which I can say that I did this because you told me here is where, and believe me, it sometimes happens. Unfortunately, many companies, and this is one of them, install at least occasional meetings in Zoom, or something between them and me, and I think it's less efficient than writing, but they want it, fine with me. So, but it's interesting because the company is San Francisco. Before I moved to San Francisco, I never have been in their headquarters, and after I moved, I also never have been there. I'm not even sure that they have headquarters after COVID. Formal headquarters. So basically the answer is writing and Zoom.
Thank you again.
I think there is another. If you have time, I don't know.
Yes. No, it's all right. The backslash round bracket, it's the AMS mass strut resetting. It's a mass char def. I can take it offline if you want. The current mass code is saved in a mass char def, which you can't do if it's active.
I'm not sure I can hear you well.
Sorry, the breaking before a bracket with backslash, you got the error?
Yeah.
It's AMS mass saves the mass code in a mass char def, which you can't do if it's hex 8000, if it's active. So you get the error you showed.
You mean the Vitruvian graphic? You mean the Vitruvian man?
You showed an error in AMS math.
Where?
We could take this off. That one. Yes. So yes. That's in reset math strut, line 693 of AMS math style. Well, I've got it in.
So which is line number again? Which is line number again? Which is line number?
I'll take it.
Okay. Yeah. Please do, because I have spent some time just, and I couldn't even charge them because I usually don't charge if I don't solve the problem.
Thank you again, Boris. The next speaker is Ben Davies. So Ben was a university teacher in physics, and now he's in the support team of Overleaf, and he will tell about the development of the visual editor, all the improvements, and also some considerations they had about the difficulty. Okay.
Yeah.
Thank you, Ben.
Thank you for the introduction. Yeah. So I'm going to talk about some of the things that we've been doing at Overleaf. I'm hopeful that I shouldn't have to explain much about what Overleaf is or what it does, because hopefully most people already know. But I've always liked this image because this is what Overleaf is in a visual way. The idea is that it's a collaboration tool that everybody works on the same version of the document at the same time, rather than having their local file changing all the time, seeking out different changes and all the rest of it. And what I'm going to talk about today, I like to think is the next step to this collaboration image. It's not just splitting the authors or the reviewers or readers into different groups. It's about looking at those groups and finding, what do these groups need? What is it that is different about the people in this group that means they maybe want to interact with the document in a different way? And so what needs are there? Well, 3 that I've captured here. My supervisor doesn't know LaTeX, but I need to work with them. Well, change supervisor for colleague or administrator or random person that I've met and decided I want to write something with, and you have the same problem. Do you write it all yourself? Do you get them to do it somewhere else and then translate it into LaTeX yourself? You know, it's just not a sustainable thing to be working with people across different platforms. You might be proofreading things. You might not care too much about the LaTeX specifics at that point in time. You just want to read something where you can make changes and immediately see a result. So you're not having to recompile, wait for that to run, and then see if you've made the right change. And then you want to learn LaTeX. There are a lot of people, and as a university teacher, I am somewhat still staggered by the number of 18-year-olds who now find code intimidating. It's scary. You show them a LaTeX document and they are terrified. I don't understand it, but that's what the classroom is like now. That's what university classrooms are like. So how do we help those people? We don't want to block off LaTeX, we want to try and get them using it, and so we need to come up with a way of helping them engage with documents without scaring them off at the first encounter. And we had rich text in for quite a while, and at the time it used Code Mirror 5, that's what it was written in, and we were able to produce previews of maths, and we did some figures, and we did some nice decorations around things like citations, and we hid certain amounts of code, but because at the time our source editor was using ACE, it meant that when we introduced features into ACE, they didn't translate across into the visual editor. And one of those key features was the collaboration features, so track changes and commenting on a document. You could do it in source mode, but you couldn't do it in the rich text. But we also kind of introduced core principle, which is that we wanted the code to be accessible. This isn't about hiding the LaTeX so that you never see it again or you can't make those changes. We always want you to be able to access the code and just write as you would in the code editor, even if you're working in the visual mode. So always making it accessible. And so more recently, what we've done is we have migrated both of the editors into Code Mirror 6. And what that means now is that the back end for both editors is the same, and the only thing that's different is your visual interaction with that editor. What that means is that suddenly all of the features that we had that worked in the code editor, as we now call it, could easily now work in the visual editor. So advanced reference search, track changes, making comments, all of these things are now working in both editors. As I say, we renamed them to Code and Visual so that they reflect how they should be used. It isn't the case that you should always use the visual editor. That might not be the best place to do the specific task that you're doing. So you switch to the code editor. But equally, there are times when the visual editor makes more sense. It also gave access to things like themes, key bindings, different autocomplete or rather the editors were using different autocompletes for some time. Now all of that is the same. And what we have is an editor where we just decorate them in different ways. And the other thing that this has allowed us to do is take a more element by element design process. So instead of trying to make a complete thing and trying to address everything in one go, we're able to make changes and bring changes in one at a time and focus on a specific type of LaTeX, think about how we want to decorate it, how we want it to appear, think about how we want people to interact with it, and then we launch that bit, and then we move on to the next bit. You know, let's look at this type of LaTeX, see how we want to do the same thing to that. This is now where I talk even quicker and probably unreasonably fast. So if you get lost, I apologize. I'm going to talk alongside a video. You're far better off just opening Novaleaf Project and playing with all the features yourselves, but I will try and cover a number of features that we have in the visual mode during the video. So if we can play the video, please. So we have the toggle to move into the visual editor, and you have a toolbar across the top, which allows us to input different types of things. So we can select the type of text we're writing, we can format it, we can put in some maths, we can have symbols, insert citations, links, cross-references. We can insert a figure, and we have introduced a new figure modal, and that allows us to import images, to choose some simple presets, and insert a figure without writing any LaTeX. So someone who doesn't know LaTeX can just put an image into your document. We can insert lists of different types and change the indentation of the code. We hide the preamble, but you can access it. You can just go in and make any edits that you want, and then we decorate things like make title, so they appear how you would expect them to kind of appear in your paper. You can click into environments and just make the changes without ever seeing the code. We decorate different types of formatting, so here we've got some bold and italics and monofonts in there, and it works as you would expect. You highlight the text, you click the button in the toolbar, and there it is. You don't necessarily need to know what's happening on the LaTeX side. If you want to access something more complex, then you can just click into the reference, make the edit, and click out, and it changes back, so you can update these things as you're reading through. There are different types of environments that we outline and make more visible, so you know that it's an interactable chunk. Again, you just click in, make the changes that you want to change, and then you can click out. You can change the styling, you can click into the caption and write the caption, you can click into the label, change the label, and then you see the pencil icon just there. That takes you back to the modal. So again, if you don't know any LaTeX, you can go in and change some of the presets that might have already been set for you. And when you click done, you see an update. We get bigger. There are some environments that we've not yet decorated, but we have highlighted out. This is now an interactive table. You can still click in and recover some of the LaTeX around it, and then make any changes and any edits that you want to, and interact with it in exactly the same way as you would the figure. As I say, we've now brought features across from the code editor, so you can now highlight things and add comments. You can turn on track changes, and you can make all of your edits without having to switch between the different editors to see the review features. Lists work as you'd expect. We decorate them, so here's a numbered list. If we're working on it and we hit enter, we automatically get \item put in there. We can put in our next item. We can also use tab to make a nested list. And we can do this again and again, however we want. And it also works the same for bulleted lists. And thinking about how the toolbar might be used here, we can also indent and decrease the indentation to make that nested list. So again, you can just work with toolbar buttons if you want. We decorate maths both inline and display. You just click in, make the change, and when you click out, you will also recover back any changes that you've made. And this is, imagine a thesis that takes, even if it takes 30 seconds to compile an overleaf, making a small change to that equation, it's just saving your time. I now want to apologize for making the maths incorrect because it's now going to stay up for a little while longer, and I didn't realize until reviewing this how irritating it made me. But we have the undo button and the redo button, and I want to talk about the power of undo. You're new, you're intimidated, you don't necessarily know anything about LaTeX, and someone sends you a link to this project, you go into that project, and you're stood and you're thinking, I can't touch anything, I don't want to change anything. Putting a big button in front of people that says, you can do anything you want, and then just hit this and everything goes back to how it was, really helps people play around. Now, you could do that all along. There is something psychologically different about putting a button there. It really helps people engage. So, what do we need to think about? Well, how can we handle more variety efficiently? So, I'm sure you're sat thinking, well, the examples you've shown, they all look fairly simple. That's all, rather trivial LaTeX. Oh, how do you deal with more complex things? Well, that's the challenge. Hopefully we'll get that. It's all about making it efficient. Yes, the best way of dealing with these things is to put them through a tech engine and see what the output is. That isn't the efficient way of doing what we want to achieve here. How much code should we hide? That's a really important, we don't want to hide everything so you never see any LaTeX and think that, or someone coming new to Overleaf thinks, oh, I had no idea that LaTeX underneath. That's not the point of this. We don't want to hide everything. What conventions, styles, things that we use, there are many ways of achieving the same result. If we provide a button for people to do it, which one do we pick? How do we decide between two different ways of doing the same thing? What I have seen, and I like WYSIWYG conditioning. Do you put people into the mindset of thinking they are limited by the toolbar? Because we're not hiding all of the code and you're able to get into it, we hope that that's not going to happen. But we do think about it. We do think about, is a WYSIWYG for LaTeX? Are the two compatible? Where do we stop? Where do we draw the line? But sharing behaviors and features across the editors, they need to work in different ways now. So although we have the same editor and although we want the features to work in both editors, the way you interact with them, the type of behavior you see may be different. And again, we've got to think carefully about how that might change. So the takeaways then I kind of have are providing parity to different code editors is difficult. And at one point in time, we had 3 different editors, and supporting all of them was taking a significant amount of developer time. Producing a new feature was slowing us down because we had to do it in 3 different ways, and it's just not sustainable. So by reducing down to one backend and moving to the system that we have now has been far better. Just because we know how we write the LaTeX doesn't mean we know what the button does. And equally, just because we know what we want the button to do doesn't know how we would write the LaTeX that it should do. And this is the crux of everything that we're doing, really. Trying to figure out how you do something that can be quite complex, how you reduce it down to simple actions and simple interaction buttons is really difficult. But providing these interfaces has enhanced users' experience. It is really pleasing I work on the support team, so it's really pleasing to see the messages which are, oh, I really like your new visual editor. I really like working in this place. And in fact, the 3 needs that I outlined at the start, which we had said, yeah, they sound like their user needs. We think they're good. You know, there's some research to support that. In the feedback since we released the visual editor, we've seen in the comments coming back that actually those needs are things that people are saying back to us. They're saying, oh, this is really good because it's helping me learn LaTeX, or I can now work with my supervisor because I can just tell them to use the visual editor. So again, it's really nice to know that by thinking about what they wanted and asking them beforehand, when we've implemented it, that is what they're using it for. So with that, I do, as I say, on the support team, so I reserve the right to redirect any questions to a more appropriate person, but I will now take any questions that you have.
Thanks a lot. I must admit that Ben wanted to make a live demo, and we waited until last Wednesday to tell him that it was not possible and that he would have to prepare a video. Thank you for taking the effort. Other questions?
So, I'm not sure how much information everybody stores, but do you have metrics on how many people are using either of those 2 tabs?
We do. I don't know the number off the top of my head. What I can say is since launching the visual editor, so we've had rich text in for a while. Since we launched the visual editor, so that's CM6 bringing the features across, that usage has gone up. And we are still seeing that usage go up. So I don't have an exact number for you, but it has increased. Ooh, Tom may have an exact number at some point. Is it 2% at the minute? Okay. Yeah, so because now all the features that were in the source code are now accessible from the rich text, from the visual editor, we're now seeing people start to realize, oh, I can do this and this is here and now I can get into access to that, yeah.
Different documents require to have different templates for the same things. So I could imagine that one document wants the table captions to actually be above the tables, another document requires them to be below. Will there be a possibility for the user to define the templates of the predefined buttons?
Yeah, so the figure modal that we've put out is our, you know, I would say is the first iteration of our figure modal. You know, it's the simplest that we can do. We will look at options of saying, well, you know, it's fairly easy to say, oh, I want the caption above or below or whatever it might be. So adding in those options works, yes. So yeah, we'll look at doing that where we can. The WYSIWYG conditioning kind of thing that I spoke about as well, that includes things like making people understand what we're showing, how we're decorating that editor is not what their document might look like. What we're doing is we're making it easier for people to write or to read or proofread their document. We're not giving them a preview of exactly how it's going to look in the final state. So getting that balance right and communicating that is, again, something that we're looking at because you're absolutely right. You change journal and suddenly make title looks completely different for you. So yeah.
Thank you.
When does Overleaf does the update of the PDF? Do I have to push a button or is this done on the fly?
That didn't have it on. So the green button at the top of the PDF, you can also do Control, Command, Enter, or S. But yes, you have to initiate the recompile. There is the option of turning on an auto-compile, which kind of detects when you haven't made an input for a certain period of time and then runs a compilation for you. But yeah, most cases you would have to manually recompile.
Thank you very much for this, because making tech available for non-technical users, you really made my life much easier. And thank you very much for this. I don't know whether it's appropriate here, but you told that you are going to redirect some questions to appropriate people. There is one suggestion. Okay, for people who work with me on overleaf projects, for non-technical people, there is a feature or absence of a feature which is showstopper for them. And let me tell you what is a showstopper. We have a corporate account. It means that you know exactly email of everybody who works with a file, but you are not using it right. People want to do what they used to do with Google Documents. When I click review, I could put the name of a person who is responsible to the changes, tag, and the system would send an email, and in very good situations even make an entry in some log and says, for example, Boris, you should change this thing. And when I resolve it, it should send email to the originator, Boris, and so on. So the lack of integration with email is, for many people, a very bad thing. And it's strange because for corporate accounts, you know all the emails, you have all the information.
Yeah, no, I certainly I will pass that on and pass on the feedback. I think the use case that you've described is something that I've heard before, we're aware of, and absolutely we're looking at, because, as you say, we want to make it easy for people. That's the whole point of what we're doing. And just to say, although the questions bit might not be the place to give feedback, I'm here for the rest of the conference. Other people from Overleaf are here as well. Give us feedback. We are here to listen. If you have feedback, please give it to us. Please, it will get passed on and we will think about it. So please get in touch if you do have anything. Yeah.
The preview of the math mode in the visual editor,
yep.
I assume that this is using MathJax.
Yes.
So this is not going to have access to any of the custom macros that are defined in the preamble, right?
Partially, not currently.
Are you doing something smart about it, is the question, essentially?
If it's in the editor, the decoration has access to the full editor of that file. So if it's defined in there, then we can start doing that, and we are looking at starting to do that and make more custom commands. So yes, Tom might have.
Yeah, just a quick comment. We are looking into two solutions, actually. One of them is we have quite a reasonable parser, so we could parse all new commands directly, which would be useful because we could parse them from other input files than the file you are in, for example, the main file. The second option is just give all the new commands because we have them to MathJax, because MathJax can parse new commands. So that's the two options we are looking into, like sort of allowing MathJax to see everything or just doing our parsing and search and replace, basically, a very simple one. So we are looking into it, but it's quite a lot of work, to be honest. So no promises there.
But the key thing is that the code mirror gives you access to everything in that file. So if it's defined in that file, we certainly have access to look at using it to decorate things further down.
Can you show us the last slide again? The very last one.
That one?
Yes, exactly that one. Would it be easy for a proofreader to insert some handwritten material like this one, histogram and handwritten formulas, as a remark to the author, for instance?
If, for instance, they used the figure modal, took a picture of it, then that would be relatively easy to do now, yes. So you mean actually annotate that document? So not currently, we don't currently support annotation as a PDF, no. Sorry.
Is it possible to see and download all of the auxiliary files that are generated during the processing the text files? Because I saw that they are hidden now, but sometimes it would be nice to see all of them and open every or some of them together.
Yeah, so next to this recompile button, there's a logs pane there.
Yes, but
if you have,
see it's one by one and we cannot see the...
But at the bottom of that, you have access to all the files that were produced during the compilation. You can download all of those files. Right. So you can't see them live, but you can see them as fine like.
How can I download them together, not one by one?
Yeah, so in that, there's a button at the bottom that allows you to download all of the files so that you can view them.
Okay, thank you.
Are there some other questions? We have plenty of time. Okay. If not, let's thank again Ben.
Thank you.
And welcome Didier Vernat. Didier is a teacher and a researcher at the EPITA, that is a French high-level computing school. I discovered, or he reminded me yesterday that he's been working on XEMAX for a long time, and a long time ago. But today he will speak about a new project ETAP, that is a graphical interface to do typesetting demos or experimentations.
Yeah, thanks. Hello everyone. Let me just start by saying how happy I am to see the TUG conference going physical again. It's good to see your lovely faces in real life, in a church. And I'm saying this with all due respect and consideration for the remote audience as well. So I think I'm going to be pretty much preaching the choir if I say, so let me see how it works. Which are the buttons? Oh. No. Down there? That direction? I don't know how that works. I'm only a computer scientist.
This one.
Oh, this one. Okay, okay.
The
Thanks.
most
okay.
used one.
Okay. Thanks. So yeah, I think I'm going to be pretty much preaching the choir here by saying that the world of digital typesetting is a fascinating domain. For me, it triggers two huge centers of interest. First of all, it has a strong focus on the aesthetics and the beauty of things. So that's the art of it. And it's also full of interesting technical challenges, and that's the science in it. The motivation for the project I'm going to advertise today is actually double. As for the science part, as a computer scientist and a researcher, I'm interested in the technical challenges in digital typesetting. So I want to be able to experiment with stuff to get a better understanding of the existing algorithms, to play with new ideas and ways to improve the existing things or try out ideas of my own. And also for demonstration purpose, and that's the teaching part of my activity. At some point in a recent past, I had an introductory lecture on the world of digital typesetting for students. It's a bit on hold right now, but I'd like to revive it in a not so distant future, hopefully. And I felt the need to be able to interactively and in a real-time fashion, demonstrate the beauty of nice digital typesetting. For instance, the subtlety there is in kerning and all that stuff. If you think about it for a couple of seconds, you will quickly realize that both of these motivations actually share two common traits, which is the need for a system which would be both interactive and real-time. I think for experimentation purpose, this is pretty obvious. You want to be able to manipulate stuff and visualize the result immediately. You want to be able to maybe hot patch some pieces of code and see if it works better or not. So it's pretty obvious, but maybe for demonstration purposes, it's a bit more subtle. And when I was giving the lecture to my students, I quickly realized that, for instance, if you want to explain and give the feel of the subtlety and the beauty there is in nice kerning, for instance, showing two static PDF pages next to each other simply doesn't cut it. It's much more striking if you have the ability to switch kerning on and off, for instance, and immediately see the characters move around. And that's my personal experience. So once I realized that, I pretty much said, okay, if my two main objectives in my professional activity shared those two common traits, being interactive and also being real-time, then there is probably no point in having two different platforms. And it's likely that a single software may be able to fulfill those two objectives at the same time. And so this is what I want to talk about today. So if you look at the state of the art, obviously you have WYSIWYG typesetting systems out there. Those systems are extremely reactive, and so they can be considered as real-time, but as you all know, they do not, in general, provide the utmost typesetting quality that you can get. On the other hand, we also have things like TUG, which is which produces very high quality typesetting. But on the other hand, TUG is not so interactive. You still have this development, compilation, visualization phases. Okay, so it's not as interactive as one could hope for. Obviously, there are attempts at bridging the gap. Overleaf that we've just heard about is one such attempt. And these are a great tool. But no matter what, none of the existing systems would actually completely fit both goals to be good for demonstration purposes and also for experimentation, maybe for a simple reason, which is that none of these systems, well, I mean, all of these systems are actually production systems. They focus on getting the job actually done, and they are not meant to let you play around with stuff and rapid prototyping things and so on, okay? So this is what I came up with. If you want to understand something, there is nothing that the DIY approach, right? So here's my attempt at a DIY approach. So the system I have is called, I'm still developing, is called ETAP. It stands for Experimental Typesetting Algorithms Platform. Whether experimental refers to typesetting, to algorithms, to platform, or to everything is left to the discretion of the audience. This is what the platform currently looks like. I have it on my laptop over there, so if you're interested, I'd be, of course, happy to further demonstrate it during the coffee breaks, for instance. But for the time being, I have a recorded demonstration that maybe you can play now with the sound, please, because there is the voice as well. So we're going to look at the platform in action for 15 minutes or so. Let's start with a quick tour of the features of this interface. So at the top right corner, this pane here allows you to select a specific paragraph typesetting algorithm. So here you have the source text, which is first pre-processed into what I call a lineup, which contains a number of objects ready for typesetting. The bottom of the GUI here will display the paragraph once typeset by the selected algorithm. You have the ability to zoom in or out on the resulting paragraph. This doesn't re-trigger the algorithm. This is just a viewport zooming facility. On the other hand, you also have the ability to select the width of the paragraph, and this time, as you can see, the paragraph is going to be typeset in real time. Okay, let's zoom in a little more. So here at the very top left of the GUI, you can select the kind of disposition that you want, flush left, for instance, centered, flush right, and the ability to justify when possible. It depends again on the algorithm that you select. Down below here you have what I call features which affect the lineup, so the original text before it is typeset by the selected algorithm. So for instance, you can switch kerning on and off. I'm not sure if you see the effect of kerning in real time, so I'm going to zoom in a little bit more. So kerning on, off. You have the ability to ligature the text, although there is no ligature to display in this particular text here. We're going to change that in a short while. And you also have the ability to hyphenate the lineup. Here it's not going to change anything, but for instance, yes, here, as you can see, there is a hyphen at the end of the first line, so depending on the hyphenation feature, the paragraph is going to be typeset differently. Okay, then you also have a number of visual clues that you can activate or not. I currently only display the characters themselves, but I can also switch that off, in which case here you would not see anything anymore. If you have hyphenated the lineup, then you can also visualize the hyphenation points, which appear here in two different ways. Orange triangles indicate the presence of an implicit hyphenation point, and there is also a blue triangle here which corresponds to an explicit hyphen present in the original text between lime and tree, as you can see. So you can switch that on or off. You can also display the paragraph box, which is convenient to spot, for instance, overfull or underfull lines. You can display the line boxes themselves, so I'm going to switch off character displaying, sorry, for you to get a better view of the additional clues here. So line boxes, you can also draw the character boxes themselves, which is actually a nice way to, for instance, to demonstrate the fact that typesetting algorithm usually doesn't care about the contents or the way the characters are drawn. It really is only interested in the characters' bounding boxes. So you can draw the character boxes like that. I can also draw the baselines. Okay, I can also display the overfull and underfull box, so there isn't any here. Let me just try to find a particular position where I could get both. So for instance, no, okay. So here, as you can see, there is an underfull box which is indicated with an empty orange rectangle at the end of the line. If I select a narrower paragraph, you can see here a slightly overfull box which is indicated by a filled orange rectangle at the end of the line. Okay. Let me try to find, yes, a position where I have both in case the paragraph couldn't be typeset correctly in that particular situation, for instance, where you have both an underfull and an overfull box. There is another nice facility here, which is the ability to overstretch or overshrink the lines. This is done after the algorithm has decided on a specific solution. So if I click the overstretch option, as you can see, the line will be properly justified, but it will be done in spite of the decision of the underlying algorithm. The same goes for overshrink, which will shrink an overfull line so as to reach the paragraph width, but this time the line would be considered as too tight according to the decision of the underlying algorithm. If you select overstretch or overshrink, as I've done here, there is also another nice clue that you can, a family of clues that you can display, which is precisely the overshrunk or overstretched boxes. I'm going to activate that now, and as you can see, without overstretching, I have an underfull box, but with overstretching, I have an overstretched clue, which is materialized here by this blue arrow pointing upward. It indicates that the line has been overstretched in spite of the decision of the underlying algorithm. And obviously at the near the end of the paragraph here, normally overfull box, once overshrunk, would be indicated with this arrow pointing downwards, indicating that the line is too tight according to the compared to the decision of the original algorithm. Okay, I guess that's it for the features of the general features of the interface. The last thing I can show you is that, let me select a wider paragraph. The text, the particular window in which the source text is displayed here is actually an editor, so I can I can modify the text in real time. For instance, I could say in olden efficient times, which doesn't mean anything, but as you can see, the paragraph is redisplayed and retypeset in real time. You can also revert to the original text. This will just allow me to show you that ligaturing works, because if you look at the word, let me zoom in again, if you look at the word efficient here, as you can see, with or without ligatures, you get different things. Nice to have a tool like this one for demonstration purposes, and maybe also to help people, for instance students, get a better understanding of how things work. Let's take the example of kerning, for instance. Let me just remove the paragraph box clue, also the hyphenation point. So the ability to switch kerning on and off like this is nice, because people will see the subtle differences in the placement of the characters. But on the other hand, my personal experience is that every time I've shown something like that to a bunch of students, there is always a number of them who start thinking that I'm actually a complete maniac. But for instance, what I would usually do is remove this and do something maybe in a more striking fashion like that. So if you look at this and you switch kerning on and off, then the people will start to notice that it actually matters. You have the ability to explain why precisely, and by the way, the ability to show this, to demonstrate this with characters, but maybe also not with characters, but actually with character boxes, may be even more striking, because if you do it with boxes like that, then you have the explicit vision that the boxes move around. It's also maybe it can also be interesting to show this on the full original paragraph like that. Okay, as you can see, the boxes move around, so this is actually quite cool. That's for kerning. The same applies to ligatures. Even in this particular case as well, I will maybe start by not switching ligatures on, explaining what that is, and then typing something like this. Let me remove the character boxes. FI, FFI, FL, FFL, for instance, and then with maximum zoom, I can show what ligatures actually are, okay? So this is actually quite cool, and again, the ability to do it with character boxes is nice, because you have the ability to demonstrate in real time and interactively that if you switch ligatures on, all of a sudden you get only one character instead of 2 or 3. So this is also actually quite nice, okay? A word about experimentation now. I suppose you've all been impatiently waiting for the almighty Knuth-Plus algorithm, and so here it is. So I have two versions of the Knuth-Plus algorithm here. A full graph one, well actually not the 2 at the power of n graph, a slightly improved version of that, but it's based on the exploration of the full graph of possibilities. And there is also the dynamic programming optimization, which is actually the characteristic of the Knuth-Plus algorithm. As you can see, even the graph, in the graph version, the redisplay is actually pretty efficient, even though it computes the whole graph of possibilities. We can maybe check that everything works as expected. So for instance, here is a position in which the last line is quite full, so it means that probably the looseness would work. Yes, with the looseness a looseness of 1, you get one more line than with a looseness of 0. So it works correctly. I can also play with the hyphen penalties. So let me try to find a position here. We have an hyphen at the end of the first line. So if I increase the hyphenation penalty, as you can see, what you get is a paragraph which is not hyphenated anymore, and this time you get a slightly different overstretch clue here, which is this empty blue triangle pointing upwards, indicating that the decision of the algorithm is respected, but the scaling exceeds the theoretical value of 1. If I go down to infinity, as you can see, the penalties become infinite, and so it becomes mandatory to hyphenate at every point. So this is what TUG does, by the way. I'm not responsible for it. Which is a good thing. So what about experimentation? Let me advertise the final feature, which is actually quite cool to have in this kind of tool, which is the properties tooltip here. So as soon as you activate the properties tooltip, you will get some feedback on the performance or the actual results of the algorithm in question if you click on the paragraph here. So with the properties tooltips activated, every time I move the mouse on a line, I will get some interesting information computed by the algorithm itself. So for instance, the line width. Here I'm also getting the scale, the scaling of the line, the fitness class because I'm using the Knuth-Plus algorithm, the badness of the line, and also the demerits. The content of this tooltip will depend on the kind of algorithm that you use, obviously. Now, if I move the mouse to the left margin here, I will get a paragraph-wide tooltip containing a number of useful information. So, for instance, the vertical size of the paragraph, the number of lines, pass-to, meaning that TUG had to use the tolerance threshold instead of only the pre-tolerance one, and the total demerits of the paragraph in question. I can also see, because I'm using the graph version, that this particular solution has been chosen out of 173 possible layouts. And on the other hand, if I switch to the dynamic version, which again gives me the same result, then the contents of the tooltip is going to be slightly different. It will tell me, as written here, that this paragraph was actually chosen out of 2 remaining active nodes. This is to be compared to 173 actual solutions if you use the full graph version. Let me make a quick transition to the rest of the live talk by mentioning something which is absolutely critical in the efficiency of this platform for experimentation and demonstration purposes. Again, all this graphical user interface actually does is manipulating a number of data structures which are also available from the command line in an interactive way from the read-eval print loop, actually, as a matter of fact. And let me just give you an example of this. Every time the paragraph is redisplayed by the interface, as you can see here happening in real time, all the GUI does is actually call a function which is called makeParagraph. Sorry for the lack of imagination. And this is a function which I obviously can also trigger from the command line, as you can see here. So calling makeParagraph from the REPL actually gives me the exact same programmatic object that is displayed by the GUI, and this programmatic object I can use the regular interface, and for instance I can inspect it with an inspector which is here, and everything works in parallel. Okay, let's switch back to the slides. Thank you. So that's the current state of the platform right now. I would like to say a word about the software engineering aspects, because for as much as typesetting is a hobby and also an application domain for me, my main research area is software engineering and programming paradigms. So this is written in a language which is called Common Lisp. It's a multi-paradigm language. So a paradigm is basically a way to express yourself in a programming language. Being multi-paradigm for me is extremely important because it's like having a single programming language which is actually like this gigantic toolbox in which there is plenty of solutions for expressing yourself. as opposed to mono-paradigm languages, which would force you to do stuff in their own way. For instance, Haskell, which is a perfectly nice and very elegant language, but which imposes a purely functional paradigm on you, okay? So one of the main consequences of using that kind of programming language and being multi-paradigm is actually the concision of the code. And as much as you're concise, it means that it's easier also to maintain, to develop, to debug. And so it's perfect for experimentation and rapid prototyping. So for instance, this gives you an overview of the size of the project. The biggest part is actually the GUI boilerplate. It amounts to approximately 800 lines of code. The implementation of the hyphenation engine, which basically is Liang's thesis, it's only 150 lines. The lineup computing, which means the pre-processing of the text before the typesetting algorithm runs, so kerning, ligaturing, hyphenation, and all that stuff, it amounts to 500 lines of code. Most of the algorithms are implemented in between 150 lines and 450 lines. And for the example of the Knuth-Plas algorithm, for instance, there is a total amount of 700 lines, which means that both versions, the dynamic programming optimized one and the regular graph one, amount to 350 lines each. So this is quite short, okay? So it means, again, that it's very easy to play around with that kind of tool. A lot of the concision of the code, like I said, comes from being multi-paradigm. So I'm just going to give you two examples of different paradigms which help me avoid duplication at most and be as concise as possible. So there is a part there is a large part, actually, of the software which is written in an object-oriented fashion. So, for instance, here you can see there is a base class at the top of the picture for the paragraph, for the representation of the paragraph objects. So a paragraph essentially has a width, a disposition, flush left, justified, blah, 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 and a number of lines. And the GUI, for instance, when it needs to typeset a paragraph, is only interested in that. But depending on the algorithm you use, a paragraph may have additional properties. So for instance, in the case of the Knuth-Plas algorithm, I know that this algorithm uses a number of passes which might be different from paragraph width to paragraph width. So I want to remember that. I also, as you saw, for feedback purposes, I want to remember the total demerits for a paragraph. So I'm going to store that somewhere. And then, what you can see here is the notion of multiple inheritance at play. A paragraph as formatted by the dynamic version of the Knuth-Plas algorithm, so it's called KP DINPAR here, is actually both a Knuth-Plas paragraph, so it has demerits, it has a pass number, but it also has a remaining number of active nodes in the active list at the end of the algorithm. But essentially, this is also a regular paragraph. So when you pass that object to the GUI doesn't know all the details. It only knows about this part of the object, and that's all it needs to type to render the paragraph on screen. Okay? But if you want to implement a properties tooltip giving you some feedback on algorithm-specific properties, then what you have is a polymorphic function which actually knows the exact class of the object. Okay? So there is a lot of code reuse like that. There is essentially no duplication thanks to the object orientation. Another way, and this is going to be my second and last example, another way to avoid duplication is to write the code as a mixture of object orientation and functional programming, for instance. So in this example, what you can see on top is a call to a function which is called mecgraph. Again, sorry for the lack of imagination. The mecgraph function creates a graph. Thank you very much, ladies and gentlemen. So this graph is when you want to compute the whole possibilities for breaking a paragraph into lines. Okay? If you want to know the exact number of possibilities and what they are, you will create a complete graph of solutions. Okay? My implementation of Duncan works like that. So there is this function which creates a graph. But the graph can be used by any other algorithm, because if you have all the possible solutions, it means that you're just not optimized, and that's all, okay? So the graph version of the Knuth-Plas algorithm will naturally use also this function to compute the graph, but there is one slight problem, which is that in the default implementation, the solutions are considered correct if the scaling of every line doesn't exceed an elasticity of a factor of 1, okay, either in stretching or in shrinking. Okay? But the Knuth-Plas algorithm doesn't do that. It doesn't only consider the stretching of the lines, it computes the badness. And if you consider the pre-tolerance or the tolerance, the badness or the stretching may actually exceed 1. Okay? So it means that I would be interested to have the full graph of solutions, but the way the Knuth-Plas decides on the next possible breakpoints is different from the default behavior. So it would be completely silly to completely duplicate the make graph function just for the case of the Knuth-Plas algorithm. So instead of doing that, what you can do, and this is happening here, what you can do is parameterize the code which computes the next possible breakpoints given a specific position in the lineup. And if you implement that through a function, then you can pass that function as an argument. And this is why why this belongs to the functional programming paradigm. This is called higher order functions. So you can pass a function to perform some computation as an argument to another function. And it avoids the complete duplication of the full implementation of the make graph function. Okay? So that's just 2 examples explaining why the platform is actually quite concise. The last thing which also is very important is that in this language, which actually is homoiconic and fully reflexive, when the program is running, you have complete and exhaustive access to every live object in the application. You also have the ability to rewrite functions on the fly, so you can even modify the code while the code is running, okay? So with a system like that, the GUI is actually just one possible front end to the live application, and the REPL, or as Barbara was saying earlier, the command line, is actually just another front end. And both front ends are completely bidirectional. You can read stuff, but you can also rewrite stuff on the fly, okay? And this helps me considerably for experimentation purposes, because it becomes completely trivial to, out of curiosity, ask a number of questions and, for instance, do some statistical data collection and create charts of any kind of stuff that you might be interested in. You just need to introspect the live application, retrieve the data you're interested in, and plot that in one way or another. I'm just going to give you a couple of examples, and that will be the end. I don't know how I'm doing. 5. That's perfect. It might be the first time ever that I will finish a talk on time. And that's probably because half of the talk was pre-recorded. Okay, so what about the graph size, okay? In 20 lines of code, I can plot that chart, which gives you the size of every graph for every width of the paragraph possible, okay? You can do whatever you want with that. What about the number of possible solutions for given a specific paragraph width? As you can see here, and that's based on just the exploration of the graph of possibilities, what you can see is that at most in this specific case, you can have up to 400 possible solutions for computing correctly a single paragraph, okay? And this happens at approximately 350 points wide, okay? This is just an example. Another example, how many overfull or underfull lines you have per paragraph width. It takes 10 lines of code to get that. How many hyphenated lines? It takes 6 lines of code, and so on and so on. What about the average scaling for every algorithm? This is what you get in 8 lines of code, and as you can see here, for instance, the green line is the Barnet implementation, so it's striking that Barnet has a tendency to compress a lot compared to the other available algorithms. What about the scaling variance? Well, as you can see, and this is comforting, you can see, for instance, that the Knuth-Plas, it's the yellow one, the Knuth-Plas algorithm has a tendency to avoid the too high a variance. Can you guess why? This is pretty obvious, in fact, because the variance in scaling means that you get a lot of adjacent demerits in the face. And by default, adjacent demerit costs a lot. It costs 10,000, I think, or something like that, okay? So that explains why probably the text algorithm avoids two-variant scaling across the lines of a paragraph. To conclude this, I would like to give you a final example, but which is also an anecdote, actually. This occurred less than a month ago when I was preparing the talk. And this, I think, illustrates pretty well the interest and the benefit we have in having a platform like that. So at some point, I was getting curious about text view on the competition. So the idea is, if you format a paragraph with somebody else than Tech, what would be text evaluation of the quality of a paragraph rendered by maybe the best fit algorithm, for instance? Okay, so the idea is simply to format a paragraph with any other algorithm and then compute the demerits for the paragraph in text term. Okay, so this takes 14 lines of code, and this is what you get. And what you can conclude pretty easily from this picture is that, but you all know that, Tech is an extremely modest guy. It thinks it's the best. But then again, it's normal, because as you always know, as you all know probably, Tech does find an optimal solution according to its own criteria. Okay? So it's comforting. It means that probably my implementation doesn't have too many bugs. But then again, I looked at the picture slightly more closely, and if you look at that particular spot, which occurs around 430 points wide, then there is something weird going on. This curve is for the best fit algorithm. At least it's not the best fit in the Knuth sense. It's my version of the best fit, which is slightly different. And as you can see, the best fit gives you a paragraph which, according to Tech, is better than the solution found by Tech. What? So I thought, no, okay, this has got to be a bug. There's got to be a bug somewhere, right? And in fact, there is no bug. It's perfectly normal. Can you guess why? Okay. Yeah, you can. Why?
The solutions sorted out because they hit another threshold from the bandwidth.
From the?
From text default bandwidth in your current level of experimentation, thrown certain solutions out, and they were accepted by classical.
This is almost it. Not exactly, but this is the direction. Any other ideas? Okay, my implementation of the best fit doesn't care about passes, and it works on a pre-hyphenated lineup. So it means that... Okay, so that's yeah. So what's happening here is that the best fit implementation will find a solution with, actually, in that particular situation, one hyphen, but Tech finds a solution without hyphenating the lineup. And what happens is that if you calculate the demerits for the two solutions, the one with hyphens is actually better, even in text term, than the second one. And also, this is, once you come to think about it, this is pretty obvious because, you know, the hyphen penalty is what, 50 by default. So it's not much compared, for instance, to adjacent demerits, which is 10,000. Okay? So I finally discovered that, and then I thought I've been using Tech for like 25 years maybe, and I never realized until 3 weeks ago that even in text terms, when it finds a solution without hyphens, it will stick to that solution, even though, in its own view, an hyphenated paragraph could have less demerits than the first one. So then I thought, how many times this happens? Okay, that's a fair question. And then it takes one line of code to get the answer, because then I computed this chart, I'm done. And as you can see, when you see the purple curve on top of the other one, it means that the demerits for the solution with hyphenation are actually less than the demerits with a not hyphenated solution. Okay, and that gives you a view of a general overview of the answer to previous question. Okay, so that's it. So very quickly to conclude. The platform now is relatively stable. I'm not touching much the internals anymore, so there is a lot of room for doing interesting work. I want to study more literature. By the way, if any of you have at hand the Barnett or Duncan original papers, I'm interested because I couldn't put my hands on those, so I would like to have those. With this platform, it will become extremely easy. I've already started doing so, actually, to think of extensions, potential extension to the Knuth+. I've got a couple of ideas of my own. Work on nice ideas for reverse detection and reverse plotting, for instance. Try out new algorithms. I also want to provide a tighter integration between the GUI and the lineup. For instance, I want to be able to modify the code from the GUI. This is not going to be so complicated, but that's just the state of the art right now. And many other things, which I'm sure you have nice ideas about, and I'm willing to hear what you think about this. Thank you very much. That's the end.
Thank you, Didier. We have 3 minutes for questions.
Not exactly a question, but a possible addition.
Yeah.
Microtype.
Microtype, obviously. Yeah. Flexible kerning, stuff like that. Lots of interesting things.
You showed us how to influence the handling of underfill and overfill boxes in your system. Is that the effect is that a refinement of the well-known latex commands, fussy and sloppy?
Yeah.
Most embarrassingly, I've never looked up their bodies.
Okay, so as far as I know, sloppiness is implemented in terms of adjusting the tolerance thresholds, right? Okay. So obviously you can do that graphically, but my implementation of overshrink and overstretch is something different. It lets this was just for the fun of it, actually, for adding one more bell and whistle, So you let the algorithm do its job, and at the end, if you spot an underfull or an overfull line, you have the ability to override the decision of the algorithm and do all kind of nonsense, like compress so much that you cannot read it anymore or anything. This is just to play around with the concepts, that's all. But the overstretch facility is not exactly the same thing as sloppiness.
Maybe you talked about, but I didn't hear it. I wonder how big is the influence of the language on the different hyphenation algorithms, and maybe also of the font, especially with the ligages and so on.
Yeah. So
and another thing, maybe you know, Hans Haren just implemented a new page-breaking paragraph building algorithm for context that uses more passes. Maybe it would be interesting to implement it.
Yeah. Okay. So about the font, currently the font is hardwired in the platform, but it's actually extremely easy to change it. It's only one line of code. Right now, I'm using a 10-point Latin modern font, but actually I have written a TFM parser library for Lisp. So I'm using that to retrieve all the font information from a TFM file, and it means that if you want to use another font, provided that the font is installed on your machine, all you have to do is change the path name to the TFM description file, and you get another font. So it's really not that hardwired.
Last question.
If I remember correctly, Knut states in the tech book that about 80% of his paragraphs could be rendered without hyphenation, and he was pretty proud on this. And in the 80s, doing the hyphenation was just expensive, but now it's not. So would you advocate having at least a switch in the engines? That would be 2 lines of code to switch off the first pass.
This is a very interesting point, and which that allows me to give you also an important precision. I am not interested in an exact replica or a clone of the Knuth+ algorithm, because I'm using a very high-level language, and I don't want to be a slave to the ancient data structures of Fortran or whatever language of the time. And one consequence of that, for instance, is that again, correct me if I'm wrong, but the way the Knuth+ algorithm is implemented is that at the time, hyphenation was considered expensive. So Knuth said, okay, we're going to do one pass without, and then if really that doesn't work, blah, 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 blah. So what I'm doing here, because let me get back to the picture if I can. You remember the hyphenation clues that I have. Oh, so this doesn't work anymore. If you remember, I have the ability to put visual clues at the precise hyphenation point in the paragraph. So I want to keep that even if the algorithm doesn't use hyphens. So the way I do it is systematically hyphenate my lineup. And then the way I implemented the Knuth plus algorithm is that if I'm in pass 1, I'm just ignoring the hyphenation points as potential breaking solutions. So it's different, but I don't care. My point is not to copy the algorithm, just the logic of it.
Thank you again, Didier.
Thank you.
And thanks to all the speakers. We have a coffee break for half an hour, so please be back at 4:30. I'm really pleased to welcome now Eberhard Lisse. When I saw his email address, I first thought, can you put the slideshow, please? So I saw that it was an anti-spam measure with NR at the end. And in fact, it's because Eberhard is from Namibia, plus he's a founder of the top-level domain NA. So that's his real address, and Eberhard is from Namibia. He has a very rich background, but you will introduce yourself. And today he will speak about Typist, that position itself as a competitor of LaTeX. Eberhard is in contact with the developers of Typist, and he will present your feeling about Typist.
Always so that the technology doesn't work when you use the technology. Besides my extracurricular activities, running the domain registry for Namibia.na, I have a day job. I'm a gynecologist. I don't do much of my night job anymore because the malpractice insurance was so high that I stopped doing deliveries a few years ago. And we come to that in due course. This place here is my alma mater. I did my first 2 years of medical school here. I recall that in the early 80s they let us play on computers very easily, and they had a big IBM mainframe, and I learned a little bit of PL1 with punch cards. Punch cards for the younglings among us are these cards that you put in and nowadays writes your note on, but you used to punch things in. In Germany, it's quite common to change medical school or law school or something because it's all public schools and the curriculum is the same. And my family comes from Aachen. Aachen is about 90 kilometers down the road at the border between Belgium and Netherlands, for the ones who don't know this. And there were a deck shop. As mainframe, they had a CDC. Didn't use it much, but they let us play with it, especially when we used the magic words SPSS. This is a statistical software that existed then already. So they gave us accounts, and they were using Bitnet. Internet didn't exist yet. That was an IBM protocol that allowed you to communicate, and I thought early on that that was cool in medicine. We used WordStar for typing letters, and when LaTeX came around in '85, I found this really cool and good looking, good output. Many of us, everybody here is the same. We're all doing this LaTeX because we like the quality of the output. I then went, when I graduated, I went to Namibia, worked for 15 years in what in America would be called the Indian Health Service in rural areas, and I mean Africa rural. After 15 years, I got bored, went back to specialize as an obstetrician, and then went back to Namibia, do another couple of years in the rural areas, and then went into private practice. During my time, EM Tech, some of us remember, on the 286 IBM, LaTeX was running under MS-DOS, not even Windows. Then Linux came, and we all use LaTeX work there, so that's my journey. I did never really have to write many documents, notes in the operating theater were all handwritten when you're working for the state, so it's not a problem, but I always wrote my things in LaTeX. My first laser printer was in '94, and I've never looked back. After my specialization, eventually I went into private practice, and there it's different. You have to write prescriptions and some things like X-ray forms because of the ionizing radiation regulations you have to sign yourself. And my handwriting is so bad that I can't read it myself, never mind the pharmacist, and I can't always phone my pharmacist, what did I write there? So you have to type these things. And if you type these things, they don't call you so much, they don't bother you during your work consultations. My staff, when we started, they balked at LaTeX. I wanted to do this in LaTeX, they said, nix, we're not working for you if we have to do that. So we compromised on OpenOffice for a year. Then LaTeX became so well that we moved to LaTeX first on Linux, and then I'm running a plain Mac shop. I've come to learn to write Perl and Bash and make, and I got a little bit of SQL in because I do my own bookkeeping. First of all, it gives me insight into my practice. Second of all, I don't have to pay the bookkeeper. Third of all, the bookkeeper can't steal, which is very common in Namibia. That's, on the other hand, a bit of an effort. We heard this yesterday in the German user group that bookkeeping is one of the biggest workload because there are so many members and so many activities, and that's a bit of an issue how to get that done. And eventually, our banks even started to deliver open finance exchange. OFX is an XML format. The bank that I used turned this off, so they only deliver CSV, so I got into tools that work with CSV. QSV is the one that I'm in favor at the moment. I used to use, for more intense, you can use a tool called Miller. CSVQ allows you to apply SQL to CSVs, which is good for grouping and summing and averaging and so on, which I used to do with GNU Data Mesh, but which is very complicated, which I don't have to use anymore. And then there is two viewers. As you can see in this blue color, every blue color is a link. So if I have submitted the slides and I've submitted a handout, if you click on them, you will be led to the corresponding website. I have Mac desktop at the practice and at home, and two laptops. One is a 30 gig Intel 13 Pro, and the other one is an M2 Silicon, and I come to that because I want to show a little bit about how long it takes to compile something. I found that after a few years, when I got physician burnout, which is a recognized diagnosis, that I could actually, if I took more time to see patients, I would actually work the same hours, but would make more money. Because patients like when you take more time. Women around going to a gynecologist, they know this. If the doctor knows what he's doing, everybody assumes that, but it's pleasant, takes time, listens properly. If you listen to a patient, they often tell you what's wrong with them. There is a certain things that you do, a speculum and ultrasound, which takes a fixed amount of time where you can't cut down time. The admin, you can streamline. If you cut down on that, you can see 2 patients per day more, and that's times 5 per week. It makes a real difference to the education of to the private education of my children. There is a simple dialogue tool that I used on the Mac. It's called Pashua for those Mac users around. Click on it, it's really cool. You can write, I'll show you some images just now. I use for templating purposes the old Perl template toolkit. I grew up with Perl. When I started to learn a little bit programming, Python wasn't even born yet. And I template Lux. Lux has the advantage is being plain ASCII, so it's easy to template. Templating Word or OpenOffice, for that matter, is not a simple undertaking. Sorry. Now I want to go 1 back, 2 back, 3 back, that's the one. As you can see on the left, you see these square braces and percent marks. They don't interfere with Lux or the LaTeX engine under Lux because for some other reason it works. But I don't see this, I only see this on the right side to you. Because my little dialogue system selects a patient and then fills in the data, the demographic data, and then shows me the prescription. For anybody interested, paracetamol is Tylenol, acetaminophen, what you get in the States. Very nice. Can easily write that. Since I only have about 20 regular prescriptions, it's quite simple to just tick them off. They come up the way I want it, and if it's not, I take the generic one, the default one, and can then manually add one into the Lux. That's how it looks in Lux. That's a little bit more interesting. That's scripting. We heard that some people use scripting, and I do this too. If I generate a VAT report, and my tax advisor hacks it in, I have to pay her for an hour. If I can generate it like this, which is identical to the website, I have to pay her 10 minutes. Okay? that makes a difference. If you have got 3 little companies, you have to practice, and if you cut 2-3 hours per month out of it, that makes a difference. It also shows here 45,000 in red. TUGs, to which we will come, can, through a tool, format a cell in color depending on the amount. Since they audit us when we claim back from them, I want to make it as obvious to my tax advisor. When he puts it in, we must prepare the audit, put all the documents together, so then we hand it in, they realize by now when we hand something in, it's always okay, so they go quick, and it's another cost factor for me. It's less time that I have to pay my tax advisor. Now we come to the main topic, is TUG ready for prime time? This is how the prescription that I generate with LUX looks after latex indenting and making it as readable as possible, removing all unnecessary stuff. Please don't criticize me because of the latex. If there is not still something wrong, it actually prints out the way it should. But people who noticed, there was somebody who noticed an error by just casually looking by it early on, which is good. It's just too complicated. Even if I only, sorry? No? I pushed the right button, but it doesn't want to. Okay. Even if I only look at between the manual and this command line, which is the prescription, and the rest on the left side and can be taken into a separate file, so it doesn't bother us. And the one on the top is generated by the toolkit. It's still a little bit complicated. The short answer, after 45 years of existence, TUG, it's not ready for production use, daily use in a medical practice, daily use in a law practice, and now I'm destroying the remote control here. For people who have to generate a lot of documents and who want to have it look in any way reasonable, it's not trivial to use. It's difficult. I mean, the combined expertise of LaTeX in this room is enormous, but I don't really know what the @ sign in make @ other, make @ other and make @ easier, what's the name is, I don't really know what that does. And that's only superficial. I know if I generate a variable that has an @ sign in it, I have to enclose it, but I don't know why. I don't care. But for casual use, it's much too complicated. It's extremely powerful. You can do really sexy stuff with it. You can do chessboards, music, and so on. It's really cool, but the learning curve is immense. GUI, we heard overleaf, very cool. But I can't put patient documents on a server in the cloud. Never mind, I'm not a German in that context. Technically, I am. But I have only 2 or 3 European patients who fall under the GDPR, even in Namibia. But I don't want to have patient data outside of my control. So putting that in the cloud in a document to write prescription, not on. LUX is there, but many like to dictate. In radiology nowadays, everybody dictates into Word straight the results of the ultrasound and the X-rays. In LUX, you can't do that. In LaTeX, it's impractical. Backslash brace, open brace, close brace. And if there is an error, then you find it extremely difficult to locate the error. So it's not, for day-to-day practical use, not really. It is slow. Or at least I and many others perceive it as slow, especially if you use Lua LaTeX. I have to use Lua LaTeX because there is a few things that is really cool to do. I can calculate the age of a pregnancy by having the last menstruation. I can generate a certain Fridays 24 weeks after the last menstruation because that's how long I'm allowed under my current medical protection insurance or malpractice insurance to deal with pregnant patients. On 25 weeks, I have to let them go. But a doctor cannot just run away from his patients, so I have to tell them in advance and I have to sign, so I have to calculate. Lua does this quickly. So I have a few other things that I do with Lua. So I use Lua LaTeX throughout, but it's a little bit slow. Americans among us know what comes now. This is a typical phrase in contracts after the recitals. 2 nerds in Berlin got master's degrees on figuring out or thinking of they had figured out what's missing in the gap between production, between Word and LaTeX. Most Word users don't care how it looks. They really couldn't care less whether they have got 3 words in one line and on a document that is wrapped. They don't care. On the other end are people who are deep into LaTeX, and there is the middle ground who want to have good-looking documents, who are willing to put in the work like I did, probably historically, because that was the only thing available. I don't know whether I would still do this now, probably yes. And then there are people who are not willing to do the work, which is the silent majority. And they think maybe that's one of the ways of dealing with this. Overleaf is another way. Granted, I liked very much what I heard today and what I saw today, but this is probably one thing. It's blazingly fast. It's written in Rust, it's developed on GitHub, like this generation of programmers do this these days, because then it comes with crates, and then the programs don't have to deal with everything themselves. A lot of things, they take sort of crates off the shelves to put it into, and that works. It outputs one-pass PDF, even if there is bibliography and citations and so on. It's extremely fast. It is much simpler to do. But it's not trivial to use. There is some stuff when you want to make changes and use the programming language, you have to put your head wrap a little bit around it, which I haven't had time yet to, but since I'm retiring in October, it'll come. It's obviously less powerful than LaTeX, but for day-to-day use, up to the level of masters, writing thesis documents like thesis, it's good enough, I think. There's an online tool like Overleaf. The link is there. There is the GitHub location, which is linked there, and the documentation is written by GitBooks, I think, and it's also there. The documentation is not totally complete. For example, they say we increase the number of languages that are included by the listings, or in their parlance, raw, but they don't show which one they include. Some small little niggles are there, but the documentation is quite good. This is the output of TUG minus help. I want to point you to the first 3 commands: compile, watch, and fonts. Compile will generate a PDF. Watch will watch the type file, and whenever you say it changes or you save it, it generates another PDF. So if you have an editor that cannot command TUG to regenerate, you just run this, save it, and you have the new thing up there. Fonts is cool, as you can see now. I just grabbed which serif fonts I have on my Macintosh. On my Windows system in the practice, which I basically used for test purposes, I have got 78 fonts. On my Mac, I have got 480 or something. On 486 or 7 since I downloaded the ones from Beg, not Crimson, what is this, the one that he uses. I downloaded this and tested it works easily. So, Hello World is the one that we usually do. I like, as you can see, the Noto fonts. That's how, on the right is how you do that in TUG. On the left, obviously, we all know what's to do. The numbers are, after a 10-run warm-up with Hyperfine, a normal time, Unix time, or on the Mac, on the command line. 1.9 is the LaTeX. 0.8 is the seconds is the PDF LaTeX, and 150 milliseconds is typed. On the M2 laptop that I have, it's half the time. So that's about 65 milliseconds to generate a simple document. near immediate, which satisfies the young generation that want to have immediate results. Oops. I'm setting now the page to 2 columns as opposed to LaTeX. If you change the columns, you automatically trigger a new page. You can't do this you can't change the columns in the middle of the page. It automatically triggers a new page. You have got section, subsection, and subsection, and as the font JetBrains Mono, which I'm using, ligates this together. On the right column, we change the numbering because the section and subsection numbering per default is not numbered. And it has got, as you can see, a lorem ipsum automatically implemented. You don't have to load a package. This is how it looks. I noticed that I forgot to put in that it should run the right column in block mode, wrapped. I forgot I would have to put a line of code in. I noticed that after I submitted the paper, I don't want to, once you submit a paper, you don't change it anymore, otherwise it always gives confusion which one they put on. So the discerning eye would have noticed. I copied and pasted, I copied 3 columns of the comparison of the TIPS website, put it in OpenOffice, saved it as CSV, and ran it through a viewer and adopted this topic, adopted the file as LaTeX document. I can also just download it into download the CSV and generate a table that has got 3 columns and has got the first line in red and every alternating line in blue. Unfortunately, there is no way of taking, okay, this is LaTeX, mark the LaTeX commands or mark anything. So one has to manually do this. Download another CSV, run types on it, run PennDoc on it. PennDoc generates a types table, and you can then bold it and make it in red. Code. Another 2-column CSV, and we come to this just now. In red is the things that I want to mention on the next page. I have to rush a little bit because I'm running out of time because I'm talking too much. So we set the font to 11 and to Noto. We import a package. This package system is, if you don't have that locally, it will automatically download it from you. That has a few advantages, so you always have got version 00.4 for this document around. But if you have a new computer and it's 10 years later, whether it's still around, I don't know. They are looking at whether they should have a latest or a stable version or something like this. As you see, it's not table, it's table X, which is loaded. This does things like like long table or super tabular. Can have it can span more than one column, like col span 4 here. The round braces are not necessary; they're just placeholder that you know which column you're working in. It automatically, if you reach the end of the page, it automatically cuts it off, and you can tell it how many lines of the first of the headers are header lines that then automatically put on the next page. Here I purposely kept the 2-column model. You don't have to keep track of the double backslash when a new line comes. You can have, it's just square braces and comma, and it's one stream. Whether you have 2 on one line or 5 doesn't matter. Every 2, it gets a new line. So we spoke shortly about the package system. Types is the table X is the table replacement. Types slides is something like Beamer. I haven't played with it yet, but that's my next little project. And then there is a glossary which doesn't come per default, so you have to download it. I also have a little project which has a glossary which I will then rewrite. I have gotten very fond currently of the Sublime Text Editor, which is available on Linux, Windows, and the Mac, which has got a plugin that you can do syntax highlighting for types, and you push a button, it compiles it into PDF. If you have a watching viewer on Mac, it's Skim, on Linux is Evans and Ocula, and on Windows is Sumatra PDF, which I think one of us has used today. I saw a Sumatra thing on one of the PDFs. Whenever you tell it to watch or you save it, compile it, it automatically fires it up again. If you use an Emacs or anything else, if you run the types in watch mode, you save it, it automatically pushes, and if you have got these two things next to each other, that makes it very quick and very easy to use. As some people who know me say, I may be right, I may be wrong, but I have no doubt. There's a few things that are missing. Floats are missing. There is no index at the moment. There is no interaction with the environment. I would like to run shell script, generate local variables, and then have types read that, for example, to generate tables and forms and submissions and so on. Shell escape is a dangerous thing, whether they want to do it or not, I don't know yet, but you run a program outside and the standard output then it gets replaced into a variable or whatever that you can then use. That's not working yet. You can only reference sections and figures at the moment. You cannot reference a line in a text that they could, or even if it's enumerated one, it doesn't show the number, it just says doesn't work. They're working on it. And if you reference, it only says section so and so, it doesn't say something on page so and so, which I would at least have as an option. Okay. Enumerate resume doesn't work whenever you go on the, thank you, whenever you go on out of the enumerate, it's like markdown, you can go levels in, but whenever you go to the first line with a plain text, it starts at 1 again. I haven't figured out how to fix that. They're looking at it. I'm not talking about the unscoped include because that takes a little bit too long. They are having a few citation styles and they're adding more from this, I think it's Jabref orientated. They're adding a few more of those. There is a roadmap which you can click which shows what their plan is. There is a community managed wiki, which is not the official one. There is a number of questions and answers. Then Ulrike mentioned barrier-free PDF is not the primary intention of why this was done, but in the long run it has to come, there is no doubt about it. And in summary, I think it's a brilliant idea. It's even as opposed to what 3Word is a project that some of you may know or not, which is a project a solution looking for a problem. I think this is one of the solutions to the problem that it is difficult to cross the barrier of entry. For smaller projects, easy to do. Bigger projects, 25 subjects, 25 chapters, like I have on one big manual, which I've written in Lux. It's a bit complicated, some stuff you can't do, but you can easily circumvent it with a makefile. It could be a gateway drug, as we say in English, or Einsteigsdroge in German, to LaTeX. Pandoc can read and write TUPs, so it's easy to take a TUPs file and write a LaTeX file. And for my sins, I had about 100 Open Office Theater operating reports, which I have translated into TUPs. It takes about 30 seconds to do with a shell script and about 1.5 minutes to make sure it's correct because it's a legal document. That can haunt me between 3 and 24 years. This is just the tools I used. I found that I am using the current version of Beamer and I said double V 3.0. All the tools that I have used are, and not mentioned, have links. And we come to the questions, if any.
Thank you, Eberhard. We have time for just 1 or 2 questions. Huh?
Okay, I tried in English. Types looks really interesting for me, and the Markdown language is very easy to use. But is there a possibility to include one package from LaTeX into the types? It's not possible. No. That's a big problem I see for this.
Yeah, there is. It's totally different. It's not using LaTeX. It's totally different. But there is a vibrant community with an average age of 14, perhaps, On Discord and on GitHub, I personally think this is a little bit unstructured, so there's too many locations where people ask questions and it's a little bit difficult to keep track. But there are some really serious package developments going on. This table package is written in the types code, okay. 7,000 or so 4,000 lines of code or something, okay. Probably AI generated. But people realize what's missing and what can be implemented in the code is being looked at.
You told me it's possible to use pandoc, so it's possible to enhance the syntax to pandoc and there enhance the pandoc to something other?
They are working on exporting to straight HTML. I would rather prefer if they export it to pandoc native. Yeah, but if it's straight HTML and they listen to the to queries, then it will translate. One big problem for bigger projects is one big problem that LaTeX has no answer to, as far as I see this, is EPUB. We cannot, or electronic publications. PDF is for print media, and it doesn't scale on small readers at all. It doesn't break the lines. So maybe exporting straight HTML and then pandoc it into EPUB is the answer. I rather would prefer if they just produced pandoc native format, and because then because internally pandoc will put it into native format and then put it out again. So it's one additional step that you have, and the more steps you have, the more complications you have. But my impression is that the more certain things are being asked, the more people read this, and the more people sit down and say, wait a minute, we can write this.
Thank you. If there is one more burning question, we can take it. Otherwise, we can always go and ask Eberhard during the breaks. Okay. The burning question.
It's not a burning question. I just wanted to add that there is a pandoc conversion already to
Yes.
types
Yes.
native.
Yes. There is a reader and a writer. I took my OpenOffice theater reports, translated them into types. Small things need to be manually fixed, so I wrote a shell script. For test purposes, I took some of my operating reports that I had in Lux, exported them to TUG, and there I can fully automatically translate them into types without manual interventions. I wouldn't do that because it can haunt me up to 24 years under Namibian law, but it's possible. Letters, the same thing. Probably it only exports the text, so you have to fill in the address manually, but it's better. It's 0.6, that's what I always say. It's not a finished product. They have introduced breaking changes twice while I was doing it. So, but as a start, as an idea, it's brilliant.
Thank you again. We now have 3 speakers. So they're coming from Masaryk University in Czech Republic. There are 2 students and their supervisor. And you already know 2 of them because they spoke last year already. Andrei and Peter, and they've been joined by Jacob, and they will speak about pattern generation. They are trying to develop a pattern generation method that covers the most languages as possible.
All right, I will start with this. Okay. Welcome, beloved tech family. It's a real pleasure to be here again at TUG. What I will speak about, what else than patterns, pattern generation and the like. Together I took 2 of my students from the Faculty of Informatics, Masaryk University, born place of PDF Tech, and we will deliver the take-home message. All we are saying, give patterns a chance to follow song from Extravaganza movie. So what we did, the story started 4 years ago. Here you see me, Andrew, and Don Knut, and we delivered the talk about effectiveness of pattern generation. And Don Knut asked about similarity of languages as far as hyphenation is concerned. And that triggered our thoughts, what could be similar in the hyphenation of Czech and language, the two languages. And the talk we delivered with Andrew 2 years ago was about development of Czechoslovak hyphenation patterns, one patterns that are better than single patterns for Czech and Slovak, beating them on all parameters, being that coverage and generalization. So that today's talk is a follow-up. We increased 2 languages to 9 ones and took Czech, Slovak, Georgian, Greek, Polish, Russian, Turkish, Turkmen, and Ukrainian word lists, hyphenated them, and did universal Unicode patterns. There are some showstoppers, as you will see, but we will show the roadmap how to overcome them. The outline is as follows. I will start with reminding you what the patterns are, what the syllabification is. Then Andrew will take the floor and speak about what he did with development of universal patterns. And finally, Jakub will show that it's possible with Judy library make Padgan basically Unicode compliant if you forgive some functionalities. So raise your hands who has already run Padgan from command line. Wow, that's nice. So I may kind of skip the introduction to patterns. So just to sum up the idea, instead of storing the whole ever-growing dictionary of words with hyphenation points for a given language, language evolves, the word list evolves, it's big, and at the time of development TUG, it was infeasible to store the dictionary in the RAM and just retrieve the word and see what are the hyphenation points. So instead of the word list, the new data structures, patterns with information that covers the whole word list is generated, and the patterns compete with each other. Some allow hyphenation and some forbid hyphenation. And they are generated in levels. The odd levels permit create new hyphenation points. Even numbers make these errors, fix these errors, and forbid hyphenation that was allowed in previous levels but shouldn't. Finally, when the patterns are in place for a given word, here you see hyphenation. 8 patterns are looked for in the tree that is stored in your format file in the precompiled LaTeX or PDF, LaTeX PDF format, and looks for all patterns that are substrings of the word hyphenation. Here are the 8 of them, and for instance, at the position between N and A, they compete the pattern 2, pattern 3, and this one. and the higher takes wins. So the hyphenation points here is there, and the word hyphenation should be hyphenated between N and Y. So Liang's patterns that are in each installation of TUG finds 89% of hyphenation points that were on Webster Pocket Dictionary with 30,000 words only at Liang's time. So these 40-year-old patterns are default patterns in each TUG distribution, and nobody cares that they only cover 80% of permissible hyphenation points, so they do not find the 10% of permissed points. They are not allowed to be changed, but that's another story. So that's the crash course, how syllabification and hyphenation relates. The idea is to have universal patterns. And what is universal here? We all share the pronunciation device, our mouth, and at this level, we are sharing the knowledge of what syllable is. Yeah? We want to hyphenate syllabifically. We all agreed that this word has this segmentation and most languages use syllabic principle. Basically, there are two approaches. One is etymology-based. The UK-based publishers, based on Oxford University Press dictionaries, prefer etymology, so the segmentation is at the border of etymology, that's stem and ending, while most of other languages tend to, and the trend is clear, towards phonology-based, that's syllabic hyphenation. And that's also case of US patterns, that's the main one generated from Webster. The changing trend is clear, at least in Czech. In 1956, there was a book published by Haller, Jak se dělí slova, How Words Get Hyphenated, and the word rozum, that is mind in Czech, should be hyphenated as prefix ros and stem This was considered as a compound word, or morphology took over the syllabic principle. While nowadays, the Institute of Czech Language suggests to be that the same word should be hyphenated just syllabically, ro-zoom, and the etymology is forgotten. So one may wonder how the lexical distance among languages plays a role here when hyphenating orthographic presence of the phonemes. We have started with Slavic languages and their commonalities, and to our surprise, all of these languages have more or less same principles, the syllable former principles, only with different alphabets. The consonant vowels standards are the same. Raise your hands who would prefer the left typesetting of the paragraph. Barbara? Well, you have to choose one, right? You are using hint viewer, and these are the options. So, who would opt for the left one? Raise your hands. Yeah, most of you. Oh, great. That supports our idea, and it's in a tradition of Gutenberg. Gutenberg typeset his Bible fixed with space, right? His main rule was, at the expense of changing width of letters, have uniform space. Yeah? And the way to go on the tablet or on your mobile when rendering your page with hyphenation in CSS3 or something, or in hint, for that you need good hyphenation. And even though there are many hyphenated words, it's better to read the left one than the right one where enormous spaces are there, right? So Frank doesn't like either, I understand that, but hopefully we agree that the left is slightly better. Yeah? Okay, so I will end my part that with the question one, should ever the universal syllabic patterns ever be developed? Should we give it a try? And based on the super results for Czechoslovak patterns, should we hyphenate universally?
Yes. So what I will speak about is the actual pattern generation we went through for the prototypes of the universal hyphenation patterns, and some things we ran into. So the main issue here, or the motivation for why we actually did this, is you have to ask, why do we need, or why could universal hyphenation patterns be useful in some cases? Obviously, the point is not to replace your usual run when you are hyphenating a book. The text you saw, the awfully hyphenated CSS text, that was HTML, and even to get at least the hyphenated text you saw on the left, which if forced you prefer, what had to be done is that the language in HTML had to be tagged. But so in the topmost HTML tag, you have to select the language. This is actually not, imagine you have a Wikipedia, the front end for that, and changing the language on the topmost HTML level is a different level of abstraction, one that's not usually supported by the templating engines. The other issue is that there's not enough pattern development know-how from many languages. So this way we could transfer the knowledge of how to hyphenate some, let's say, Slavic languages to some other more low resource languages, because there are really a lot of languages for whom the patterns have been developed in the 80s, in the 90s, and these were done often by hand. And as computers get faster, there's no reason to use patterns that are not the best ones available. So all this stands upon this essentially hypothesis. One is that if you pick languages among which you cannot generalize at all, completely different languages like Russian and English, we have found that you still only get linear growth in pattern size. This is not trivial, and this is probably not what you would expect, because you can't just use, a pattern can't just look at the word and guess, oh, I guess this is English, I will use the English set of patterns. The second requirement is that the same words must be pronounced the same. Patterns cannot keep sentence context in mind, as I mentioned, and if they are pronounced the same, then the same patterns can be used. If these two things hold, you can develop patterns for this set of languages. So why can't we just concatenate all the patterns? Well, we can, but the issue is on the fourth bullet point, and any is the prefix that says no in Czech and Slovak, and probably also other Slavic languages. And the issue is that this prefix doesn't mean the same thing in all languages. So it had to be dropped to level 3 from level 1, because otherwise it would just because this way it can be overridden this way it can be overridden in case this pattern is actually used for a language that is not that does not have any as the prefix. And to my surprise, the biggest issue I think we faced was essentially acquiring clean word lists. All we needed was to get lists of words in languages, and if possible, many languages, because we have the current hyphenation patterns from TUG-, and this was a much bigger issue than we expected, really. Thanks to lexical computing, we were able to acquire word lists with frequencies for 11 languages. They were fairly clean. These were just very clean word lists where there were actual words that actually occur in that language, not intermixed with some other languages. The other issue is that for many, many languages, there's no source for clean hyphenation data available. We were very lucky when we developed Czechoslovak hyphenation patterns that there was the Czech Language Institute and the Slovak Language Institute who were able to provide a list of words that were hyphenated, and this way we had a ground truth against which we could benchmark what we were doing and how successful we were. There were naturally also words that were the same but had different hyphenation in Czech, Slovak, or Polish, or between Ukrainian and Russian. And it is insufficient, obviously, to solve these issues case by case, as what we're trying to do is develop universal hyphenation patterns in for languages which we do not understand, possibly. It's not easily discernible whether the conflicts are truly words that are written the same, but pronounced differently, or whether there are simply errors in the data, in which case we just give preference to the patterns that we believe to be developed more recently, or the higher quality patterns. We have explored a few different approaches, including just asking language models, is this a word that is written the same but pronounced differently in these two languages? And we had some success with that. But generally, a scalable approach to cleaner data and conflict resolution still stands as a challenge for the future. So, as the goal of this work was to just verify the sublinearity of hyphenation pattern size or linearity of hyphenation pattern size growth, the focus wasn't really cleaning the data, and for that reason we just picked a really simple generation workflow. We essentially just hyphenate all the word lists, looked at the conflicts, picked an approach to resolving these conflicts, and then just generated patterns and studied how these patterns would have hyphenated the word lists that were before hyphenated by the old patterns, and if there are any changes. So this is the output of the generation runs. As you can see, the universal patterns are quite a bit higher. Custom ones are parameters that we picked to make sure that they would not be afraid of making mistakes, such that we can see which parts of the word list the patterns essentially think are wrong and where we should look for cleaning the data. Yeah. And essentially, along with this, the hypothesis was proven. You can actually hyphenate the words the same because we were able to, with the correct optimized, get bad down to 0.04%, which is a very negligible amount. This is the result of tenfold cross-validation. What this suggests is that the data are still very, very noisy, and that the patterns, that the universal patterns were not able to very easily learn the patterns inherent in how the other languages were hyphenated. In other words, this is suggestive of more noise in the data. This is essentially our result, uni-hyphen.pat, but we don't think this should be used yet. Yeah. We use only 9 languages in our pattern generation, and the current patgen is a showstopper for fully fledged universal patterns. We need full Unicode patgen for actually universal patterns. And I'm passing the floor to Jakub, who has done the work towards the appropriate extension to patgen, because the issue is that, yeah, I'm passing the floor to Jakub.
Hello, my name is Jakub Máca, and I would like to say a few words about the Judy and how can this data structure be used in patgen to solve the problem of only possible 245 characters. Judy is dynamic data structure. It's implemented as a tree, but most importantly, it tries to effectively use the cache memory and avoid unnecessary access to the main memory. Because of this data structure is fast, memory efficient, but it's much harder to implement than other data structures. In my bachelor thesis, I showed 2 main things. Firstly, that when working with patterns, Judy can be faster and more memory efficient than try, which is data structure commonly used for working with patterns, and it is currently used in patgen. And the second thing I showed in my thesis is that patgen can be rewritten with Judy, but with one slight problem, and that is because patgen is currently using the tree as the main data structure, but it's not implemented as some tree structure with nodes, but it's implemented as simple array. And any node in this array can be accessed with index in a constant time. But the Judy can be only accessed on a global level with operation like search or insert. And this means 2 things for the new possible version. It would require rewriting a majority of patgen's code, and secondly, it would probably be 4 times slower than the current version, but it would enable generating Unicode patterns. So the Unicode will be on the output, input, and also inside the patgen as white characters instead of the current 1-byte characters. And that's all from me.
Okay, so for me it remains to conclude and sum up. So what is the outcome? We can create universal syllabic patterns that with covering 97 plus hyphenation points. Still, we have very good generalization performance, and that is performance on unseen words. And we are able to have no errors, as the very few of the errors we might add as a patterns to the, as a whole word patterns into the set of patterns. So virtually no errors of universal syllabic patterns, at least on the input word list. What's needed for that is adding wide character support in PathGen and TUG or hint or whatever engine would need to load the Unicode patterns. And what has to be changed is either using Judy or change the implementation of PEG3 in those languages for storing patterns for a wide character support. So all I am saying is give patterns a chance, and for that we will say it together with John Lennon. Come on. Oh. No internet, sorry. So all we are saying is let patterns a chance to have singing and dancing hyphenation in all text successors or browsers like Chrome. And what remains to be done, and I would, or we would be happy if the tech community answers these questions or comment on that possible development. Thank you.
It's very interesting. I would think that people who study phonetics and linguists who study phonetics, they have some classification of languages based on phonetics. It would be very interesting to look at the patterns and see whether it correlates. I understand that a lot of languages with different phonetics as those for which there are no writing system or not many hyphenation and so on, but it would be very interesting to look what people with phonetics who study phonetics say about this work.
Yeah, I am citing in the preprint that is up on the web page for this conference and will appear in Tugboat. I cite several papers of phonetic research, and for instance, there is a application or paper that covers phonetics segmentation of 9 languages or something like that. That is shared among those languages. That means conditional random fields are used for machine learning of segmentation, phonetic segmentation of these languages. On top of that, there are those consonant vowel rules of constituting syllables, and these are based on the classification of phonemes into consonants and vowels, and this is again shared among the languages. So the consonant vowel syllable forming rules are universal as well. Yes, so
You showed us at the beginning of your talk the relationships between European languages. Do you think that your method can be applied to each of the clusters?
Each of
the clusters that you showed on the map of the relationships between languages?
I am optimist, and I think it could be applied to all languages where there is a common agreement on syllabification, hyphenation. And the difference is only that hyphenation is allowed also on syllable formal places where the segmentation is ambiguous. For instance, in Czech word sestra, it's possible to segment sestra or sestra or sestra. But common agreement is that there should be 2 syllables only. So once one decides on consistent markup of input word list for universal pattern generation, then I think the 9 languages could grow to 100 or even more. And that is a roadmap for having really Unicode, universal patterns that next browsers would simply use to hyphenate for blocked typesetting or just any typesetting.
And to answer the question more practically, I believe the first step would be to make sets of patterns that cover the whole language families. So for example, all the Slavic languages that are written in Latin. And then we can expand towards, and then we can gradually expand these sets of patterns.
Yeah, the technology is capable of covering basically all patterns, all points in the input word list. And when you remove some unwanted or colliding points from there, still having 90% plus hyphenation, allowable hyphenation places, then which is better than Liang's patterns, you can have, I'm sure, universal hyphenation.
Okay. One more question, maybe? Yes.
There's one thing that's not present in any of the present hyphenation patterns that I know of, I could be wrong, and that is the ability to distinguish between primary hyphenation points and secondary, which is preferable. And that's something that I would, especially with long technical terms, you can get yourself into real trouble.
Yeah, that is orthogonal issue. One possibility is to use several levels to generate compound word, the primary hyphenation, then fix that, and on top of that generate another levels. Currently there are only 9 allowed, but probably one would need much more, and generate the patterns that cover the rest. And then in the hyphenating engine, when the hyphenation point is found, look whether the hyphenation is there from the first part, the compound word part, or whether it's from the rest part, second part, and according to that, set hyphen penalty accordingly, with preferences for compound word and the rest. So that's the solution, and it's orthogonal to universality, right? So for that, you only have to have the word list with these two types of hyphenation patterns, hyphenation points marked, as German did for their word list.
Okay. Thanks again, Andrew, Jakub, and Peter.
Okay.
And I would like to thank all the speakers of this afternoon. That was really great talks, really interesting, and I really want to thank you.
because formally it's our thing, but we probably will have